There we go. All righty. All yours.
Good evening, class. Today, I would like to talk to you a little bit about what my team has done for this project and to give you enough details so that you may follow in our footsteps. All three of us have had programming experience prior to working on this project. However, none of us had any experience with SQL or data servers in general. For this project, we use Visual Studio 2019 to set up a simple data server. And then with the help of a Visual Studio Code extension, we use queries to connect to the server and input, sort, and retrieve data from it. I'll be talking a little bit about how we set up our IDEs and a little bit about what queries are, and then we'll do a short live demo. Finally, we'll conclude with things we've learned and what we do differently if given the chance. Feel free to ask questions in the chat during the presentation, and my team member will collect them and will provide answers for them at the end. So let's jump right into setting up the IDE and getting a data server up and running. For our demonstration later, we are going to be using Visual Studios and Visual Studio Code. If you already have Visual Studio installed on your computer and you didn't install, or you are not sure if you installed the SQL related packages that are shipped as optional workloads in Visual Studio, then you'll have to reconfigure your IDE to include them. To do this, we'll click on Tools at the top of the screen, then click on the Get Tools and Features. The Package Manager window will pop up, and then you'll select the .NET Desktop Development Package and the data storage and processing package, and install them. Now that the IDE is ready to host our data server, we'll have to create a new project using the SQL Server Database Project template. Select File in the top left corner of the screen, mouse over New, and then left click on Project. In the new window that pops up, you'll type in the search bar SQL or database, and then left click on the template that says SQL Server Database Project, and click the next button at the bottom right of that window. In the next window, you'll be able to name it as you wish, and then click on the Create button to create it. Now that we have a database set up, we are going to need some way to communicate with it and be able to input data into it. To do this, we will be using what are called queries. Now you might be asking yourself, what is a query? Queries are nothing more than the programming methods that are used to request, input, or edit data and information within a database's table, or a combination of tables. To create a new query, click on Tools, mouse over SQL Server, and left click on New Query. This will create a blank .sql file and bring up a new window titled Connect. In this window, you'll be able to connect to your desired source. The first query we are going to need is the create table query. This function needs to be ran first so that the database has a table in it for the other commands to operate on. If it is not ran first, then every other query will give you an error saying that the object name is invalid. This function also requires that there is a column labeled primary key. The purpose of this key is to keep the data organized. However, it is not always necessary to include the key when inserting new rows of data. Instead, if we add the parameter identity parentheses 1, 1 parentheses after the primary key command, then the server will automatically assign new rows with unique IDs. The next command here is the drop table command. It simply removes and deletes a table from the database. The third command here is the insert into table values command. This command does what you might expect. It allows you to insert specific values into the specified columns within a table. Something special about this command is that it allows you to insert multiple rows of data into a table at once. The update table command is another special command. This one allows you to edit the specific values of a specified column within a table as well. However, when it comes to updating multiple pieces of data at once, unlike the insert command's ability to add multiple rows of data in an instant, we will need to issue multiple of these update commands if we want to change multiple other columns to different values. The alter table drop column command works similarly to the drop table command in that it removes and deletes something from the server. In this case, it will remove and delete a specified column from our table. The delete from table, where the column equals a value command, allows us to tell the server to remove an entire row of data. The final command I'll go over tonight is the select from table command. This one allows us to pull data from the server and display it. Secondarily, it can also take extra parameters after it to give the outputting data some sorting rules. The asterisk in this command here denotes a wildcard, and so the command will try to pull everything from the table when printed. Now I'll hand the presentation over to one of my teammates for a live demo.
All right, so here we have Owen opening up his Visual Studios to show us the demonstration. So here we're going to create a new project in the section that Owen shows us. And then from here, we're going to select SQL for our programming language and our database. And then here we get to name it like a fun name. But for this demonstration, we're going to name it database 3. All right, so we have our server set up. So from here, we're just going to go to we're going to show our tools for our server. And from here, we're going to download our extensions, I believe. Oh, no, sorry, these are still our tools. So .NET desktop development is what we're going to need, but this should already be installed with Visual Studios. Same with data storage and processing. From here in Visual Studios, we're going to go to so here we're going to download our extensions. So for SQL, so we will be downloading Dino, which is a communication that will directly target the language server. So it'll be easier for us to get the codes that we want to work with SQL. So from here, we hit insert, and then Owen's going to click on SQL insert rows, and it'll show us exactly what we need to insert values into our data table. So here, this is all the stuff that we've already worked on. So our table is already created. And these are the values that we wanted for our tables. So we have ID, name, age, source, character category, traits, voice actor or actor, place of birth for the character, and then character notes. And then here where Owen is highlighting 50 is the amount of characters that we're allowed to have in that certain category. So for name, it can't be a name over 50 characters. Same with age and all the rest of the values. And then the primary key identity, how it's labeled 1-to-1, is the code for auto incrementing. So here Owen's going to load up our table and chart. And our chart has been successfully completed. And from here, select star from characters is our chart and table. And the star is kind of like a wild card. So it'll basically bring up everything from that values. But since we haven't included anything into our values, we're going to show you a demonstration of that. So here we're inserting the IDs, age, values of 11 characters, I believe, into our table. So once we have this, once we run this, it's going to be effective. And here we'll run the code again, and then it'll show us all of our values, names, all these characters. But we also notice that there's a same table or same identity for another character. So what we do to fix that is we go to deleting a row. Where we insert the code delete from characters, and then where it says where ID equals 13, that's the row that it should delete. So here we'll update it again. And then restart the process. And it deletes that row. So now we're gonna go update our table. Because we noticed updating a table can basically replace any data point wherever in the in our chart. So we're gonna update one of the traits in row 10 and add traits for one of our characters, Obi-Wan Kenobi. And notice how in the traits it's empty. And for row 10, it will be empty. And there we have our traits. So now let's say we don't want a couple of the columns that we inserted. So here we're going to drop a column. So we have the table, the drop column, and then which columns that we want to drop. Oh, and then we have to put alter table to fix the drop column. So here the code was successfully ran, and traits and character notes are deleted from our chart. And now to delete a table, we hit drop table. We run this code. Code was successfully ran. And now that we go back to our table, it is gone. No more database 3.
What was the hardest part of getting all this working?
Honestly, just trying to find the right extensions to get this working. I think the hardest part for me was just trying to figure out how to drop and like drop rows and then delete rows. That was the hardest part for me.
Yeah, because for the rest of the class, Dino is a rewrite of Node.js. And it has a lot more security written into it. And basically it allows you to create a full stack on your local PC. It makes things painless. And I believe the author of Dino started out life as a mathematician, statistician. And when he put together Node.js, it was to solve a problem he had. And it took over the planet. And then the bad guys took over Node.js. So if you see Node.js in production, it will probably be in a Docker container or some sort of a VM because it's going to get infected and then they have to trash it and rebuild it. So there's a slow migration happening to Dino because it solves a lot of these poison packages issues. And when it comes to drop column and null, back up your data. When you do a alter table drop column on the payroll database and they're about ready to print checks, you better have a backup. It's
That's good to know.
yeah, but doing what you did, you gave yourself a really good rounded understanding of how SQL interfaces with a database. Now, what you just did, and in the syntax that you used, I could roll an Oracle database under that, Postgres. You pick the database and your SQL commands will most likely work. It's the individual machine manipulation commands that are somewhat different. That was very good because it was interesting that you guys, when you called me to ask for some help on this, I don't know visual code. I know SQL and databases, but I am duly impressed. Microsoft has made this much easier to jump into the world of SQL without having to take a crash course in VI and the Linux command line. So in that respect, that was good. Other questions?
There's still a little bit more to the presentation.
Okay, fire away.
Okay, so I'm going to continue with what we learned. My team and I learned how to set up our IDEs for SQL development, initialize the database server, and connect to that server. We also learned about what queries are and a little bit about how they work and some of the basic commands used with them. We learned about the commands to create tables, add data to those tables, manipulate those tables, and how to pull and sort the data from those tables. Now, with everything that we've learned, oops, went too far. With everything we've learned, it's easy to see what we could have done differently. One thing that we attempted to do but were unsuccessful with was to have one of us host a public data server and then have the others connect to it.
Hmm.
This would have been great for us to have done because it's kind of like the entire purpose of having a data server in the first place.
Mhm.
And it would have helped us to build up an even larger data set for this presentation.
Mhm.
We'd also like to have done more research on some of the more advanced database server functions, like setting up custom security and permission rules, or making tables reference one another. And like most people on last Tuesday, we wish we would have started a bit sooner. If we had started sooner, then we would have had the extra time to do the research that could have made this project into something more than it turned out to be.
Yeah.
I hope that our presentation has given you some guidance and ideas on what to expect if you ever decide to dive into the world of SQL for yourself. Lastly, I'd like to leave you with a quote from Stan Rapp, a database and marketing entrepreneur that we think demonstrates the importance of databases in the modern world. In the 21st century, the database is the marketplace.
Yay and amen to that. For keeping current on modern SQL syntax and which database has what new things in advanced syntax, like there's a window command, there's a pivot where you can do pivot-like tables inside of SQL. And modernsql.com will actually show you which databases support some of these new fancy keywords in the SQL language that is just mind-numbing, because one new command like the window command replaces literally hundreds of lines of code in PHP. So it's really it's worth your time to learn SQL because it's just getting better and everything's in a database anyway. So it's a great tool to learn. All right. All right, who wants to go next? That was phenomenal. Good job.
Thank you.
All right, go ahead. We do, me and Nathan. Unity, oh, fun.
All right. Can you guys hear me?
Yes.
All right. So me and my partner, Amir, decided to do something in Unity Engine, specifically a ping pong game. And this was something that we had been brainstorming. So we wanted definitely to do something in Unity Engine because of its popularity and because it's something written in the C# language, which is something both of us don't have experience with. And it's a new skill set we definitely wanted to add. So we also wanted to get into the idea of game development because both of us do other things in programming, but not really game development. And we kind of wanted to step outside of our comfort zone a little bit. And so for the design and pseudocode of this game, we had to decide on the parameters because the ping pong game is it's built around like an arena and two paddles. So we had to decide on the midpoint of the arena, the size of the arena, and the size and the sides on which the paddles would be on, so left and right, and the shape of the ball and the walls. And next thing we had to do was we had to make sure that the sides of the objects we wouldn't make them like too large, so basically it'd be impossible to score on one side, and on the other side it would be like whatever, because if you make one paddle too short and the other paddle too large, it's an unfair game. And if you make the AI have a larger paddle and you have a smaller one, then the game becomes difficult for you. So we had to decide on the fairness of this, and by doing this we had to make sure that the sizes were appropriate. So first we had to do the coding script for the ball, So the speed of the ball, it wouldn't be too fast or too slow. Because if you do, then you would just have like rapid fire games, or it would just be really slow and it'd take forever to do anything, which is something we didn't want to do. So we had to give the ball more speed as it bounces off the objects. So the paddle or the sides of the games or the side of the arenas. And then we had to set the ball in the middle position after each reset. And when the ball would shoot out, it would be, the angle would be random. So no player has a specific advantage. And after scoring on each side or the other, the ball resets back to its normal position. So we also had to figure out that on Unity engine, which is pretty cool about it that we learned, was the physics is already built in. So we didn't have to start from scratch for a physics engine, which would be really hard and complicated.
Yeah.
So the ball needs to bounce on all objects. So the paddle, walls, and the surface, when it collides with the ball, it has to speed up like it would normally in physics, like in the real world. So yeah, this is our coding script for bouncy surface. And then the coding script for the paddles. So we had to make sure that the computer could move up and down, so the player could move up and down too. And they have to be given the same speeds. Like you can't move faster than the computer and the computer can't move faster than you, because then again, it would be unfair. And each time that the player scores or the computer scores, the position has to be reset. And the collision detection of the ball and the wall, it has to work. And if it doesn't, the game, it would be like a glitch, it'd be broken. So, and this is where my partner takes over.
All right, so yeah, so coding the player paddle was primarily simple. Since we're dealing with a 2D platform instead of a 3D, we don't have to deal with like three-dimensional, like you have to X, Y, and Z type of stuff. All we have to focus on is X and Y, or mainly just Y. So it's simple just to put, just move the paddle up and down by using W and S key is really simple just to inputting it in onto the code. And it also has to be reset after any party scores at all. Yeah. So for, when it comes to the computer paddle, the computer paddle is actually an interesting one because it's not being controlled by anyone except the computer. The way that the computer can, the way that you can play against a computer is that it follows the ball at all times. So once you start playing, it's following its position. So it's not going to be like in one position all the time, which is not be really boring. I mean, we'll just play it against like a dead player. But it's important to have the paddle follow the ball at all times. And once the ball's speed does increase over time, it causes more of a challenge with you and the computer. It causes that more of a fun mechanic over time. And also it does reset after any party scores. Now, the game manager. This one's a cool one. This one's also built on the Unity itself. Basically, all I have to do is just put it on the script, call in a game manager, and it's already built onto it. All I really needed to do onto this one is to concatenate all the scripts into this to basically make it functional, per se. And including this concatenation with all the scripts, we also have to add a counter onto the console log, whoever scores, so it doesn't seem like a dead scoring game. And it's not gonna be like trying to keep a scoreboard on by trying to write on a side of like a piece of paper like Battlefield 2042. But hey, that's just me. Yeah, it keeps a log on by itself. And in the talking of the scoring scoreboard, go ahead. We made our own scoring zone. That's right. We showed something that guys cannot do. But anyways, yeah. So for each side that scores, either like a player or a computer, it adds 1 point on either side who scores, and it resets everyone's position and starts over again. So quick little side note, putting that onto the Unity engine itself, like trying to like angle it, was really, really difficult because the shape of the field itself is normal, but the shape of the scores are really, really big. So I have to make an execution file trying to angle it. Looks a little bit too left, too much on the left. Gotta fix that. So I have like 12 executionable ping pong games just stuck in my trash files. And I mean, that's pretty much it with this Eddie's screen. I like to share my screen to showing you guys the script and whatnot.
All right, sounds good.
Yep.
All right, you can go ahead, Amir.
You guys see my screen?
Yes.
Which one is it?
All right, so here's the code in C# for the ball coding script. And so right here on the public float speed, we have a variable set to 200F. So basically that's a normal speed, because if you put any less or any higher, like it just, let's just say it'll look really weird. And then the interesting part around here is like Amir said, the X and Y. Since this is a 2-dimensional game, we don't have to worry about the Z axis, because if you do 3 dimensions, you would have a float Z variable. Right here, we have to look at the points. So think of it like an X and Y plane in math. So it goes 0.5 F, so that's to the right. And then the negative 1.0 F value, it takes you to the left, because the left side is negative, obviously. And then right back is a 1, so it takes you back to the starting. And then the float Y, this is where it gets interesting, the random range. So the negative 1 F, it goes down on the Y-axis, and then the same part, it goes down again, because the parameters of it are negative 1, 1, and then up 1, down 1. So that's like how your X and Y axes are set. And then the range would be 0.5 to 1. That's top, bottom. And that's for our coding script. And then you have to make sure that you put the functions for the physics, because the Unity engine already has it. You just have to put add force to the rigid body, so the ball is working. Like it'll work, because if it doesn't, it'll just stay there. So you want to move on to the next script. And then this is where we have our bouncy surface. So again, Unity engine's pretty cool, because you just have to call on the command to make sure that the collision and of the object, like it hits and it works in the game. Because if you don't put any of this and you miss any step, it's just the game won't work, which is like one of the challenges that we had was if you miss any part, it makes me respect games more, because you really notice like there's going to be some sort of glitch on here, but thankfully we were able to figure this out. And then you can move over to the paddle. And then this is our paddle speed. So our 10 is our variable speed, which is this doesn't change. This stays constant, because if it changes, the variable speed of it's just like it'll look glitchy. Like if you go from, let's say 1 to 5, like random variable rate change, like the paddle could either speed up or move down slow. Like it'll just look wonky. Like when you open up a web page and it just looks all funky. But that's why you have to keep it constant in games sometimes. And that's just the way it works for this game, since it's 2-dimensional. And the rigid body, so you have to make sure that the paddle itself will like stay, because there's some physics engines where like if the ball hits the collision, it'll start like denting objects, or it'll just change the physics of it, because it is a physics engine. You have to keep these things in mind. And you also have to keep in mind the vector forces. So right here it says new vector, position X, 0, 0. So it keeps things relatively stable as it resets the position. You want to move on to the paddle player?
Yep. So like I explained earlier, it's really easy. Just put like a key code, like W, S, up, down, arrow key. And yeah, I mean, and this one's also like adding speed to the paddle's direction. Someone did ask a question on the paddle speed. What does it say? Give me 1 second. Like how quickly does it? It doesn't have like an actual like value of how fast it goes, but if I just pull up the Unity Unity engine. You can't guys can see it, huh? Hold on.
You have to share the screen.
No, not this one. No, not right here.
Or you want to wait till, yeah.
Yeah, I just wanted to show like the player paddle. There's actually a set speed right here we can put like right here. So if we set this to 15, it's either going to go like 15 meters per second up or down. If you put like 100, it's going to go fast as a bullet, you know. But yeah, let me continue on with my code.
All right.
So yeah, this adds to speed, this adds to control, and this one, don't freak out. This is not spaghetti code. Okay, this actually works. So yeah, this actually follows the ball's position at all times. So if the ball is at like in the northern position, it's going to be at that position. If it's going to be on the bottom, it's going to fall to the bottom. And yeah, so if the ball speed is faster, the paddle speed will also catch up to the ball speed, trying to catch up to it. Scoring zone, there it is. So it's boring when you're just trying to keep a tab on a separate piece of paper, trying to see like who has more points than the other. It'd be better if you just see like on the screen, it's like, okay, these developers aren't lazy. They're actually showing like who's having like more score than others. And yeah. Yeah, it's pretty much
Last script.
Yep.
So this
last
is
script. Last but not least, so this is mother of all Mary. These are all the programs that we previously mentioned. We just all concatenate all of them into this game manager. And we also added a player score counter onto the lock system. So, and as well, if either one scores, it would automatically resets everything to its normal position and start again.
You want to execute the program?
Yep. And I do have an executable game to show you. Let's see if I can actually show my executable code. So, give me a second. It's on my files. Let's see. There you go. You guys can see it?
I can't see it.
I'm not sure. Come on. Hold on.
I think you have to go to it.
Screen one. How about that? You guys can see it?
Yeah.
Yeah, there we go.
There we go. So this is the computer on the right. I'm on the left. So you see how the ball speed does continue getting faster over time. And sometimes it does that, and sometimes it just launches at like 10,000 miles per hour. But this was like primarily it's like easy to make, and this was really fun to make too, especially for the computer. There was actually a bug where the computer paddle didn't go on the bottom at all. It just stayed only on the top, and I was really confused why. And that's because one of the 50% numbers is supposed to be supposed to be on the bottom. It was a positive, so it was actually saying, oh, the ball's on the bottom. Oh, stay on the top. And yeah, I mean,
so for sure, what we learned was don't underestimate games. They're a lot harder to make than people think. And if we decided to go 3D, we could definitely implement like Blender. Like, I don't know if you guys have messed around with that program, Blender, and do 3D models for like rackets, tennis balls and everything, which would be pretty cool. But, you know, sometimes they ask you to pay for those models if you can't design them yourself. Because there's like web pages for that. But it was pretty fun to work on this project at the Mir, and we definitely learned some stuff, and game development is pretty fun.
I just got my ass kicked by the computer. All right, but yeah, that's basically it.
Awesome.
All right.
Very good job.
If you guys have any questions at all, please let us know. We'll be happy to answer. I mean, if you do have any questions.
What was the single hardest part of this particular project for you?
Getting
I would say the physics, making sure that everything is the values are working together, because sometimes you would just have game breaking glitches, like how he said, but you hit the ball and it'll like shoot like a bullet, and you're like, yeah, that's not
I mean,
it's not gonna work.
It's a lot better than before, but like there's some parts of the walls where it's just stronger than the other, and somewhere it's just completely other way. But yeah, I see like another thing that's like really hard to do is trying to get collisions with the paddles and with the ball, because trying to get that actually like executable, because we were having issues when the ball was hitting the paddle, it wasn't having a bounce at all. And that's when we think, oh, why don't we just make a bounce surface? Wow. Think about that.
Here's my paddle. Here comes the ball, and it sticks. Yeah.
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 Yeah, but
Fine.
it was fun. I mean, I was thinking about like making actual games in the future, but after making this, I'm reconsidering my major. But,
Well,
you know.
yeah, you know, that's but learning how to code to do this sort of thing, where the big money is you take your gaming and apply it to business data.
Mhm.
For example, a fellow professor who works at Sandia Labs, Ed Walsh, was telling me he was working with some interns that took a gaming engine and they gut out the game and they added this data for voters. And then what they could do is they could see heat maps of the United States of who was voting when and where in real time or near real time. It was updated like within a minute. And I said, that's danged amazing, because you sit there and have this visual of the map actually going red, blue, purple, and whatever colors you need to actually see real time things. And the other one is like, you can find the maps on the web of flight traffic, real time flight traffic. And a lot of that's the guts for gaming engines. So yeah, there's a place for it. That's for sure.
Yeah.
Fascinating stuff.
Thank you so much.
All right. Thank you, Professor.
I have a question, Professor. Is there anything like with coding or anything you want me to turn in, or just leave it like that?
Yeah, if you turn in the PowerPoint and jog my memory,
Okay.
that's enough. Yeah, very nicely done.
Thank you.
Good
Thank you,
job.
Professor.
All right, the next one's ready. Aaron and Nathan. Raspberry Pi VPN. How fun.
Can you guys hear me?
Yes,
Am I too loud or is this kind of good?
it's good.
All right. And actually, me and my partner are actually here at my house together. So we'll just both just like take turns on the mic.
Okay.
Once he's done, then I'll hop in. All right. So for our project, we did a Raspberry Pi VPN. So just get started. Let me see. So what is a VPN? So for a lot of people that maybe don't know what a VPN is, which most likely you should know if you're in this class, but just in case, it's a virtual private network. It's a way to use and add security and privacy from a private or a public network. And also it allows you to access files. For example, let's say if you're working for a company, they set up a VPN so you can access remotely a lot of folders and, like, for example, a lot of things that you need access for your company from your own network. And then what is a Raspberry Pi? So for a lot of people that don't know, Raspberry Pi is like a small little computer that you can basically run anything on it, but mainly people usually run Raspbian or Linux. It's also very small and it's usually very affordable compared to any other computer. And also it's very low in power consumption. And also it can be used to set up multiple things, but mainly they're usually meant just to do like one specific thing. Like they're mainly set for one purpose. So for example, on this case, we have a little Raspberry Pi and its purpose serves as a VPN. It's kind of better and like more cheaper and smarter than, obviously, let's say building an entire PC just to run a VPN just for your home network. Wouldn't be very too smart to do that. So that's why you just buy a Raspberry Pi instead. Now, the reasons why you would want to do this. So for example, one of these things would be that to stop your internet provider from watching you. So this is mainly more of a problem in other countries where, for example, like some countries like China or other places where they're very strict. The internet providers are very strict with what they visit and stuff like that. So they're very known for using like a lot of VPNs in their home networks. Also, it also protects you from different apps and services that usually constantly track like everything that you visit or stuff that you basically access online. That's how basically ads are generated and stuff like that. And to some people, they really don't care about this, but for a lot of other people that care more about their security and their privacy, this can become a very big issue. Also, it also protects you from a lot of malicious ISPs. So for example, anything that has to do with security or intruders and stuff like that, this can help you a lot. It also, for example, like I said before, like in a lot of countries like China, where a lot of their content is blocked or geofenced, this also helps them bypass that. Or for example, even here in the US, a lot of people like to watch, for example, let's take Netflix, for example. There's a lot of shows in Netflix that are actually accessible in other countries, but not in the US. So a lot of people usually create a VPN so they can access those TV shows or movies that are basically geofenced or restricted here, and they're able to watch it. It also helps for a lot of people in other, for example, in other countries with government censorship and to unblock the websites. And one more reason, a last reason, which I don't promote or anything, but I'm just saying that's what a lot of people use it for, is for pirating things. So they'll pirate movies or pirate other sorts of content and video games. Again, I don't condone or promote any of that, mainly because I don't want to get in trouble. But yeah, that's one reason why you can use that for. Some milestones that we basically just had three main milestones in mind. So first of all is we all, well, at least I and my partner both knew what a VPN is, but we truly want to see exactly how a VPN works, not just what it does, but how does it work and how does it function? And also, of course, we want to see how we can make our own. Not only just simply like how a lot of people use a VPN where they just go to the app store or they just download a program from like another VPN. There's a lot of out there like NordVPN or so many different companies that all you do is just install it and activate it. We kind of want to see what's the difference between that and one where you have like a dedicated computer, like a Raspberry Pi, where it's basically your own VPN. And then third, the benefits of this. So for example, how would this be useful and would it actually be useful to use on day to day? So to prepare for this, some of the things that we needed, some of these things we already had. So we had, like, for example, we used the Raspberry Pi 3, an 8 gigabyte micro SD card, minimum, and then also an SD card reader, an HDMI monitor, keyboard, an internet cable, and a power supply, and of course, an internet provider. So the overall process for this was that, just like kind of simple down, was that we prepared to install the Raspberry Pi operating system. So this is installing Raspbian into the Raspberry Pi. And then after this, we created a static IP address for the Raspberry Pi. And then we constructed a VPN on the Raspberry Pi. Then after this, we had to build certificates for the VPN. And then after that, we just named the server. And then after this, my partner Nathan here will take over and he'll just do his part on this slide.
For sure. Well, so once we started, all we had to do was first flash the Raspbian like OS onto an SD card. Formatted the SD card first of all in FAT32 so the Pi could read it, and then flash the OS on there. We were gonna just use a monitor and a keyboard and mouse to set up the Pi and everything, but we found out you could do I figured out why we couldn't SSH like right off the bat from flashing, and it's because you need to add an empty file that's just named SSH onto the SD card after flashing, and that will enable SSH without having to first connect to it with a keyboard and mouse and then set it up on the device itself. You can do that, but I didn't realize that until that's one thing I learned is I had to do that. So we did that. That allowed us to just do everything headless, which was just very nice, because the Pi can just sit in its little corner and you could just connect to it. So we updated its repositories, updated its packages, and then updated the OS on it, because sometimes the OS straight from the websites aren't always updated. So we just did all that beforehand. We installed WireGuard on there, which was our service of choice. We wanted a WireGuard instance on the Pi so that we can connect. That would be our VPN service. It's free to use, and I've heard very good reviews on it. We decided on that. We wanted to do open, we wanted to try other services as well, but we just decided on WireGuard, just because it
Yeah,
was we like.
WireGuard is the most modern,
Mhm.
you got IPsec and you got an open VPN. WireGuard brings a lot to the table because they also support hardware. So you get used to this, you can scale it up and get a WireGuard chunk of hardware and support a VPN that handles 95,000 users. So their stuff scales very well. It's pretty awesome.
Exactly. So I had heard all of that and I was like, we want to try that. So we ran it on, we installed it. Then we had, once we had everything installed, this is just a screenshot of my Mac connecting. So, okay, sorry, I'm getting a little ahead of myself. I have at home a media server that has Plex running on it. Plex media server. It was also talked about earlier by another classmate, but Plex is a great service, right? And I have all my movies, TV shows, music on there. And sometimes I'll be going to another person's house, and I have a bag with me that I carry everything in, my laptop, phone, charger, and everything. Sometimes I'll be at a friend's house and we'll want to watch a movie. I'll find it online, and I want to add it to my media server at home so that I can update Plex's scan library files, and then it'll add it to the library, and then we can watch it on Plex, which is all polished and nice and everything because it'll grab metadata for you and everything. So the problem though would be I couldn't do that from another person's house. I'd have to do that locally through SFTP, just transfer the movie file from my Mac or wherever I have it to the media server so that the server can host it and stream it. So that's kind of where this idea came from. I wanted something practical. So we decided to do this so that I can be anywhere as long as I have an internet connection. I can connect to my home network and connect to the media server that I have as if I was there locally from anywhere I am. So I thought that was perfect because that's exactly what I've been looking for. And so when we were looking for an idea for this class, I thought, yeah, that's pretty nice. Aaron and I decided to team up because we had known each other for a little bit. We didn't know we were taking the same class. We're like, you know what, this is perfect. He already has access to my Plex server as well. So whenever he wanted something, I would always just download it for him, put it on there because it doesn't cost me anything, right? But now I can let him have access to the VPN server, let him have his own tunnel access to my home network. I trust him enough for that, known him many years, but my point is he can now add his own stuff. I can even add his own user to the media server machine that I have running Ubuntu. I can give him his own little access, like login and everything, and he can have his own space on the hard drive to add his own movies and stuff. And I feel like that's perfect because then he can do everything independently, and I don't really have to worry about it. And he can do it from his house. He doesn't have to be at my place for anything of that. So this screenshot right here is me remotely. I know I can't really prove it, but it's me remotely accessing my media server on the right through my Pi VPN. So I'm somewhere else off of my home network, but I'm connected to my VPN, which is running off of the Pi on my home network. I had to port forward it and everything. I think that was a little bit of a challenge because every router has its own thing. Some don't even label it as port forwarding. Some, so I had to dig for that. But once I found it and figured it out, set it to UDP, port 51280, and then I had it work, and I was like, this is great. So now I don't have to worry about it's a practical use is what I'm trying to say. So the use for this though, you wouldn't really want to do anything that you shouldn't be doing because this VPN is just sitting at your home network. So if you do anything somewhere else while connected to it, it'll be as if you're at home. So it's not really going to hide anything from your ISP, your home ISP, because they'll be able to see everything that you're doing because it'll be as if you're there. So this VPN, the use for this is really only just to have access to your home network. It's not really for anything like that. But in this instance, it serves its purpose. So the success is just a really low res image of the Pi in question, but we updated its repository, successfully port forwarded the Pi's address so it can have access from the internet, from outside the internet, copied over the conf file to allow Aaron to access it, and transferred movie files off and on loaded files from the home media server successfully from a remote location, which is exactly what we wanted to do. So how to expand, just to make this project bigger, because it was really just to prove that we could do it. We want to make it bigger by having our own NAS. This was mentioned by another classmate, that they wanted to do like a VPN service so they can connect to their home network and access their files. Well, we're kind of like doing the opposite, where we did the VPN, but now we want to have our own cloud storage at home. Especially that would cut down. We both pay for subscription services, so if we split like a 10 terabyte hard drive on a system and set up a NAS on that, and then the VPN on that, then we'd be set. You know, we'd be able to offload and onload files as on the go, and we would cut out completely you know, all the big tech companies, especially how someone mentioned that they're not really reputable and don't have the best track records when it comes to being trustworthy all that much. But you know, they say if it's free, it's because you're the product. You're the product. So yeah, so that's it. We're that was our project. It works. It's great. And happy browsing, everyone. Yeah, that's pretty much it.
Awesome. Now with the WireGuard, do you have to install a client on foreign PCs, like, or do you have a browser that automatically downloads the client when they hit your IP address?
The way we did it is we just downloaded WireGuard's clients on our clients, because it's cross-platform, right? And
Right.
so they have the iOS app, you know, Android app. So we tried it on iOS, Android, Mac, and PC, and it all worked perfectly fine. We just copied over the configuration file, and it worked perfectly fine. Yeah, and we checked just to prove that it worked. You know, I would SFTP into my home media server and just check IP addresses to see if they would change, and yeah, and it worked beautifully. So WireGuard was amazing.
It's a slick tool.
Exactly.
Very well polished. You know, for open source, it's very well crafted. You got a question in there in the chat.
Oh, sorry, my bad. Wasn't really paying attention. Let's see. Do you think that the Pi0 W2 would be capable of hosting similar VPNs for 2 to 3? Yeah, I would say so. The W2, yeah. I would say so. I have a W, not the 2, but I forgot what it's clocked at. I forgot this model that I have. This is the Pi 3. Has enough RAM and power to handle this. I mean, this Pi in question that I've had, I've even ran Plex on it before. I haven't tried to do a VPN thing like that, so that's why we decided to do it. But it ran Plex, and it was a little iffy for transcoding, right? Because that takes power. But for just streaming, if the client could stream the video natively, or could accept the video natively, and it didn't have to transcode, it just had to stream, it was perfect. I would have like 2 or even 3 users at a time just streaming. If there's no transcoding, it could handle it. But I'm not really sure about this Pi0 W2 though.
Yeah, I've got a Pi 1, 2, 3, 4. I've kind of lost track of how many Pis I have
I think
lately.
we're at 4 right now.
I got the 4 with the 8 gig, and that's actually an impressive little box. You know,
It's
got
crazy for being so tiny and so cheap. You can do some things with it.
It's like almost a desktop replacement if you don't do too much.
Yeah, I've seen some people that literally have like a portable desktop, and all they do is just carry their Pi around, and then they just connect it to a monitor, and then they can do like simple things like browse the internet, access some files, whatever they need.
Yep.
Better than nowadays building like a $5,000 PC computer.
Yeah, no kidding.
It's great. All right. Anything else? I think that's it for us then. So we'll go ahead and stop sharing.
Did you blow up any Pis in the process?
Thankfully not.
They were not.
The first Pi we did was the one that worked. No.
Yay.
Yeah, we were scared about that too. Sometimes like don't want to over push it, but nah.
Yeah. Phenomenal. Great job.
Thank you.
Thank you.
Good job. Who wants to go next? Jump on in there. All right. So share the screen. That's how you get in first. Share your screen. All right.
Okay, can everyone hear me?
Yes.
All right, I've been talking for the last 30 seconds and I was muted, so I
Oh.
enjoyed a nice little conversation with myself.
Kind of like me at the beginning of class.
Okay, so what I did, my goal kind of after this class is once I finish and got my degree, I want to work on some networking certs and maybe get into some security as well. But I figured, learning VMware, learning how to create and manage virtual machines would be good for that. So I had access to it via On the Hub from last year, I believe.
Mhm.
And then just installed it, set it up. I'm just going to kind of walk through what the setup is. The first thing I did after getting it all set up was I downloaded an ISO for Ubuntu and I installed it. And honestly, it was a lot simpler than I thought it would be. I really didn't know what to expect. I didn't have any experience really with VMware or creating VMs through any other software at all. So I was just like, oh, we'll kind of just go play it by ear and see how it was. And it's pretty self-explanatory in terms of just creating machines. The wizard is super simple. Right from the home screen, you just click that create new button. You can create custom machines or, the express way, which worked for everything that I did. You choose where you're pulling the image from. So this is a 21H2 ISO for Windows. And it'll kind of auto detect what it is based on what the ISO is. You just go through. I'm not going to install it because obviously that'll take some time, but you can name it anything that you want, tell it where it's going to store that virtual disk space on your actual drive. It's just going into the VMware folder, virtual machines, and then whatever the machine is named. You can create disk size. It's got some different options to store it as a single file or split it. Just depends on your use case. You can customize your hardware in here, and it's really nice and simple UI. It's just a slider. You can punch in by megabyte, or you can slide. It gives you some recommendations, the maximum allowed based on how much you have recommended for what you're installing and the minimum recommended. You can give it different numbers of processors and different numbers of cores per processors if you want to enable a virtual multi-threading. You can add virtual CD drives, you can add virtual network adapters. What I did differently than what's recommended on here is I just gave it full bridged access, which kind of bit me in the butt when I was trying to set up something later on down the road, which I'll talk about. But as you're just installing a basic machine, NATing can be used to just basically it piggybacks off your host's IP and it just provides it network access. And then when you've got it all set up, you just finish, it'll create your machine, and then it goes through the boot. And in this case, it's just installing Windows. If you've ever done that before, it's exactly the same as how it normally would be. And so that's what I did with Ubuntu and a Windows machine. And then I decided, well, why not go a little further? And I installed Windows Server, and I actually made a little kind of mock home domain, just a little local domain, just because I figured that'd be fun to do and it'd be interesting to see. So I got a Windows Server 2019 ISO from Windows, had to give them my email so they'd provide it to me, and instantly started getting marketing notifications. Gotta love Windows. After I got it installed, I'm just gonna go ahead and resume it here. They were going through updates earlier, which again, lovely Windows always needs to update when you don't need it to. I got it installed, and what you're greeted with once it comes up here, first time you log in, it has you do your setup, of course. Always create secure passwords. What it starts you out with is the server manager window. And the first thing I did off the bat was I knew I was going to need it to be a domain controller. So I just kind of started messing around, fiddling with things. Thought, I'll try to get it all done on my own before doing stuff online, just because I'm a bit of a masochist, right? I guess. Wound up looking up some tutorials as well, just because some of the settings that weren't working for me and it was not properly accepting the role, but got it provisioned as a domain controller. Just created a local domain, which once it populates here, yeah, see, so domain, just greer.local. Wound up adding these other two Windows 10 VMs onto it. Joined them up to the domain. I added the RSAT, so Active Directory tools, created a couple user accounts. I made test user and test user 2. One's a domain admin, one's just a regular domain user. Joining them to the domain, I was having some trouble with. I spent probably a couple hours just on like various forums trying to figure out why it wouldn't join the domain, because I'd punch in the info to try to get it to join, and it wasn't working, and it seemed like it wasn't talking to the DC at all. And then I realized, since they had bridged access, they were pointing to my home router for DNS, which was screwing with talking to the domain controller. So once I pointed the other Windows 10 VMs to my server IP, which I set as a static IP, joined right up, no issues there. Created accounts, signed them in, just kind of started playing around in the environment. Created a shared folder through the tools in here, which is just being hosted right off the C drive. There's just a test share here, which I opened up, and I mapped it onto these guys here. Let me resume these so I can just show you how it looks. So just mapped it on here, put a couple different files in there, and was kind of messing around with assigning permissions to different files. One thing I found was on this user here, I gave them permission for both the little text files in here. And then on this other test user, I wanted to try and hide one. And there is a setting in the Windows server, which was called, I think, just access-based enumeration or file enumeration, something like that, which allowed you basically, if you didn't have read access to the file, it would hide the file. So here's my little test share. I can open up the properties. Access-based enumeration. That's what it was called. It took me a minute to drill into here and find this as well. But what that allows me to do is open this up here, if it opens. Which apparently it's not connecting to the share. That's lovely.
Don't you love real-time demos?
Oh yeah, it's great. I feel like I'm back at work. I do tech support for Modesto City Schools, and this is just like home. Here we go. So, of course, gotta have a homework folder on your computer. Got my to-do list just for tonight. But then if I log in on my domain admin, I've also got another file that's not there because I removed read access for test user 2. And then you can hear my biggest secret, which figured was pretty fitting for today because I really didn't know what I was doing when I was setting all this up. It was really fun. One thing that I tried to do but failed, again, I think because technically the network was being bridged with my home network in the router. I tried to set up the server as a DHCP server, but it was already getting DHCP from my home router, and trying to bypass that was a little weird. I would have had to change up the network adapter settings, and I just decided it wasn't really worth it because this was kind of a weird case that this was being set up anyways. But I was able to assign the role and mess with the DHCP settings a little bit. Just I got it provisioned as a DHCP server, just couldn't get the two domain computers to connect and actually get addressing from there. But yeah, that was my foray into virtual machines, setting up a little mock server or server and a domain. It's a lot of fun. I didn't really know, like I said, anything about VMs or anything about creating domains. I have worked around them in various work environments, but I didn't know anything about managing them. So it was good. It's fun to get some experience under the belt.
Yeah, the Active Directory Windows domain is slowly but surely taking over how people manage users.
Mm-hmm.
So it's kind of a big deal to understand it. If you look at one of your settings in one of your VPNs or one of your VMs,
Mhm.
you have an host only option as far as networking.
Yeah.
That host only does
Mhm.
just that.
Mhm.
It will create, you could create your entire domain as a host only. All your machines and server has a host domain. And then on your server, you had a second card that goes to bridged or NAT, and it server becomes a gateway or a router to the rest of your internal network. So you can actually mimic in software setting up a complete hardware-based arena. So that's going to serve you well for learning more about networking and security.
Oh,
For
yeah,
example, you
definitely.
set up a machine that you want to penetrate. How do you want to do it? You know,
Mhm.
so very good.
Yeah, definitely. One thing I wanted to do was actually set it up on a physical machine. I have an old computer case. I was thinking I can just get some basic hardware and just use it as a VM host that I can then connect to the network. But I didn't have hardware to put in there, and it was between buying hardware for that or buying myself a new graphics card, and I chose more frames in my games. And I figured I could do this all in VMs anyways, and
Yeah,
it'd be a good opportunity to learn this too. So
yeah,
that's the next step. Is I actually want to set up a home server, um, you know, have it act as a NAS, and also install like Plex, which seems to be pretty popular around here.
yep.
Get some experience in that.
And get a bunch of Raspberry Pis.
Yeah, I have a Pi 4 with
Yeah.
it's a 4 gig kit, so
Yeah,
I don't have 8 gigs of RAM, but
well, that's okay. The 4 gig,
oh
it's
yeah.
got the nice thing about the Raspberry Pi 4 is that they bring gigabyte Ethernet to the equation. All the previous Pis are 100 megabit only. Most of the time, that doesn't bother you. But then when it does, it really bothers you.
Yeah, if you're talking about sharing files, 100 megabits sounds like a lot, but if there's more than one client trying to connect to that thing, it's
Yep.
not a lot.
No. Yep. Fun stuff. Any other questions? Very good. Very good. And be sure to post something so I can, it jogs my memory. It's nice that it's being recorded.
Yeah, I've
this
got
is-
a PowerPoint that I'll post to
Okay.
that too. But
Okay.
awesome. Yeah, let me stop my share. All right.
All right. Who wants to jump in?
Okay, so can you guys see my screen?
Yeah, it looks like my server rack.
Okay, so here,
There we go.
yeah. So I have my project. I didn't get as much time as I wanted to work on it because of changes in the team stuff and all that.
Yeah.
So
Human
I
factors. I get
did
it.
what I could. I had this is like my backup project that I had in case anything went wrong that I could maybe like handle on my own. So then at least be able to do something and not have anything, or at least have something to show for it.
Okay.
So I chose to do like a little custom OS on an old Android device that I had. And so then I had to learn about how the Android software operating system works. It's very complex and it has many layers, as you can see over here, all the stuff. It's built on the Linux kernel. Basic Android is based off of the LTS branch of Linux, so long-term support, and it was actually changed to have even longer support because of actions that Google had taken to convince Linux people to support it for longer. And then Android itself is supported and controlled, I guess, by what's called the Open Handset Alliance. And it's devs, but also like uh, telecommunications companies, manufacturers of phones and all that. So like uh, phone service providers like T-Mobile, AT&T, Verizon, stuff like that. And then OEMs like Google, Samsung, and anything you can think of that has to do with phones is involved in that sort of alliance. Generally speaking, most software that you see if you have an Android phone is just like proprietary, and then a lot of this stuff is like custom made for each individual device, because most, as we'll see later, I have a little bit of more information on it. Most devices have like custom drivers so that they can actually run the hardware and software together and have it all work properly. And so then, even though Android is kind of open source, each individual flavor that you see on a device isn't open source. And so then the proprietary stuff, such as like the Google Play Store, YouTube, Google Drive, in pre-installed apps like your phone app that you make calls from, your messages app, your calculator, stuff like that, and like even down to like the system UI itself, like One UI and Oxygen OS from like OnePlus or something like that. It's all like proprietary. And so then I chose this one because I felt that like a lot of people are just kind of throwing away old phones and old devices that may still have use or may still be able to like function, instead are just like buying new stuff and continue to feed into that. Some companies are like pushing a little bit towards that same thing. Like Apple is kind of doing it. They're realizing that people are keeping their phones for longer, but some companies say like OnePlus isn't one of them, where they keep making new ones every year for people to buy, and some people keep buying them. So the team was just me. Originally, I had a group that didn't work out. So then I went solo, and then this is the project that I used as a solo group. So some milestones that I had to meet. I had to learn a little bit about the Windows command prompt, because it's not exactly the same as the Linux terminal. There's some things where it's like just entering commands is like similar, but there's some very key differences that you need to know in order to be able to execute certain things on Windows. Generally, because that's what I use on a day-to-day basis. I also had to learn about what's called ADB, or Android debugging tools, in order to be able to take control of the device from my computer, in order to be able to flash the OS software, and then the recovery software and anything else that I might have needed. So like basic apps like the phone and messages, stuff like that. Uh, Learn about the Android architecture. I had to do that in order to make sure that I could find and then ensure that it was compatible a version of Android other that was not from the company that made the phone, so that it would work on the phone and then it wouldn't cause me problems. And then also learn to manage my limited amount of time being so close to finals with all my other classes. I had to learn about the recovery software itself. And so then let me pull it up. So this is a little bit of information on the recovery software, if you guys can see it. To say TeamWin, Twerp, something like that. Twerp is the recovery software that you can download and integrate into any capable Android phone in order to have like sort of like how you have a BIOS menu on PCs, but it's for phones. And so then you can do certain things on that over that software instead of loading into the normal operating system that you would use on a day-to-day basis, which will then allow you to say integrate root, integrate the new software, integrate packages, even sometimes it's just like install apps that you may want that you may normally not be able to just directly install like you would normally through, say, like a app store or something like that. Let me go back to this. I had to learn about the software that I wanted to install for the OS itself. And so then I chose Lineage OS, which is a OS that they generally dedicate themselves to like supporting older devices and like having support for those devices that like may no longer be used, or even say like that are still somewhat useful that may have not gotten the life as long of a life as they deserved. And so then finally I also had to learn how to fully, or at least try to learn about integrating Google Apps onto the phone, because I wanted to be able to continue to use it like it was a normal phone, which you'll see later a little bit, maybe talk about how to do that. And then I have a little sort of guide, I guess, on how to do it. It's fairly generalized. I tried to make it as general as possible because most of the time certain like aspects of the installation process you need to go more specific depending on the device. Some devices are more locked down than others. I heard like one device manufacturer, you have to give them like your phone number and register with them in order to be able to unlock your phone at all, in order to be able to install their OS and install your own stuff like the twerp and your own OS that you want. And so then I have a couple of screenshot and then a little bit generalized like things that you need and then the process itself. Okay, and then after doing it, some capabilities that you can do, some things that you can have that you now have because of having the custom OS and stuff. So if you want, you have to add it on yourself manually. You can't just unlock it. You can get root access to the phone itself if you want. It's like another separate thing that goes on with the recovery software. But if you want, you can have root and you can control the device down to base level and all that, and all the benefits that it provides. You can filter content, say like ads or something like that, block trackers or some such that you don't want on your phone. You can have your own custom apps that you may need to have a little deeper level of control so that they can actually function properly. You, at least on mine, I'm not familiar with others, but I know for sure Twerp allows it. If you install Twerp, you get access to a Linux terminal on the phone. So it's like another app that you have, and you can just type away whatever you want to do. Certain commands don't work on that terminal, but that's down to the phone itself and not necessarily the software. When you do root, you can overclock and underclock your phone. So the central processing unit, if you want, you can make it run faster or make it run slower, and then that can change the performance of the device, but potentially risk damage to it if you're okay with that. And then you can also like update your phone to higher versions of Android. So normally my phone would come with, let me see if I can pull it up. So this is my phone when it originally released. It has originally from the factory up to Android 6, but currently I am running Android 9 on it through Lineage OS. Let's see, I have a screenshot and pull it up later, but okay. So here, the OEM Oxygen OS 2.2.3, that's as far as it went. And so then that comes with Android 6. And then I had the stock Android and / Google apps, such as like Google Drive, Google Phone, messages and all that. And then the camera seems to be a little better on the original software versus on the custom software that I'm running now. I have Lineage OS 16.1, which is the one of the ones that was like fairly compatible. I had to do minimal things to do it to get it to work. And then I have a newer version of Android on it because of Lineage OS. And then Lineage OS comes with its own like custom Google apps. It's fairly similar to the original ones, so like your messaging and your phone, your contacts, stuff like that. But they're a little bit like scaled down. It's kind of just a reskin. And then I have access to multitasking if you have like a newer Android phone, you know that you can have like multiple apps running at the same time. And so then originally I didn't have that on my phone, on the phone that I flashed the software, but now I do because it's a higher version of Android that supports it. And then I also have some enhanced security and privacy features that are integrated into Lineage OS that generally most manufacturers don't bother to add. So overall, I learned some things through doing this project. Android itself is like its own company within Google, and then Google eventually bought it and all that. And they originally wanted to create like an advanced camera operating system. That was the original goal of Android, but as you can see, Android is no longer that. So, and then like I was talking about earlier, basic Android can't run on any device. It needs to be like edited, customized, whatever, to be able to run on any device. Every device has its own specific drivers in order to be able to support the hardware that it has in order to be able to run anything at all on it. And so then the variations that certain devices or certain manufacturers have, say like Samsung has two different versions of whatever phone they're selling. They have like European / Asian market phones, and then they have US phones. US phones have an entirely different processor than European and / Asian market phones. And so then that entirely like it's a fully different experience almost because of the changes that they have for the region. And so then that also affects the speed and quality of updates that devices receive. And so it's changed my perspective on how often and how much phone manufacturers like update their phones and software and all that. Android itself is made up of several different layers, as you guys probably saw on this slide right here. And then, so it's based on the Linux kernel that houses the hardware drivers, the HAL that allows for communication between different level systems, but lower level. System services, which includes stuff like the notification manager and search service and stuff like that. The binder IPC that allows for communication between apps and system services. So like apps being able to access your clock on your phone, and then the app framework, which is what most people see on a day-to-day basis, that allows them to use their apps and make sure that they run. And then I think this was shown in a presentation last week, how Android has its own development platform for apps that you can then emulate phones and have those apps run on that development platform, and then be able to like send them out and analyze it and make sure it all works for most devices and stuff like that. So overall, some areas of success, I managed to install twerp without issues. It works pretty well for what it does. And as far as I've been able to use it, I haven't had any issues. Lineage OS is on there on the phone, and it works too. And then because of the stuff that comes with Lineage OS, I now have a greater level control over the phone and like the system settings and stuff like that. Some system settings that normally wouldn't show up under normal circumstances or normal operating systems. But some things that I wasn't able to do, so I wasn't able to fully integrate the G Suite apps package. So that's like YouTube, Gmail, Google Drive, stuff like that. I had to use a package that was just purely Google Play, and that was the only package that was like compatible with my flavor of Lineage OS and the phone itself. But I at least can still download like apps from the store. But having just the Google Play Store is fairly limiting. And then, like I talked about earlier, the custom apps that are there are just like sort of reskins of what the Google apps are. So like the phone and contacts, stuff like that. And then I personally didn't root the device, which is something that I could have done. I didn't want to waste time, possibly like losing out on other things that I might have needed to do, work on, stuff like that. And it, like I said earlier, it's a separate process from installing twerp at the same time that can then let you do other things if you're okay with that. And so then if I was to do this again, I generally, the changes that I would do, I would try and root the device. If it's possible, try and use a different recovery tool. So twerp, use something other than twerp, see how it works, see if it's any better, see if it provides any better features or something like that. Or even, and then possibly another change that I would do is try and use another OS, or even say like customize one to try and work and put it on the phone. And then some other minor things, like see if I can like maybe develop an app or integrate the G Suite apps, and then some other stuff like fixing the phone and then replacing battery, stuff like that. Some hardware stuff like doesn't really have too much to do with like installing the OS, but it's something that would help with the longevity of the device. And so that's it. But I do have, let's see, I do have some stuff. I have this, so I'm gonna pull up ADB tools and connect to the phone. Devices. And so then that's the device right now connected to my phone through USB. And so then I can do So now I am running a terminal from the command prompt that's connected to the phone itself. And so then say like I could do that, and then now I'm running bash on the phone, exit out, exit again.
Now, when you install in that level down there at the Android level, do you have access to the GPS and the accelerometer and all the other little things that are
Generally, generally speaking, most Android devices, from the looks of it, as far as I can tell, the ones that I have and the ones that I've used, you already have some sort of like access to it, but you can't control it. With root, it doesn't really change that much. As I said, I haven't experienced root 2 too much, but it doesn't change to a whole lot because it's just a sort of like base level service. And so then now I've restarted ADB as root, and now you can do other things if you want. And so then it's connected again. And
now
so
you're
then,
through. Yeah.
yeah. And then bash changes to
Do an LS,
but
do an LS minus L on /proc. Yeah, space. Well, use the slash, the directory slash, the proc, PROC as in process.
okay.
Yeah, so
Yeah, so sometimes they don't work. I've noticed certain commands. It just depends on the device.
I get it, because it's actually a very stripped back operating system.
Yeah.
And
Yeah.
I'm curious. Well, anyway, I typed it in the chat. That's what I'm trying to get at.
Oh, okay. Let me pull that up. I can't see the chat. I have
Oh, okay. Well, it's just LS space.
okay, I see.
Yeah. The highlight, copy, paste.
Oh. LS.
Yeah, from my view, it's really, really, really tiny.
Yeah. Let me don't think I can make command prompt any bigger.
That's okay. It is there. So now that proc file system is what's built dynamically when your machine boots.
Yeah.
And all this stuff is temporarily built. Every time you reboot, it sometimes changes, sometimes doesn't. But this is where, things are stored in RAM so you can kick off things. And it's interesting that this is still all in the Android. This is good to know.
Yeah.
Yeah, I haven't played around with embedded systems enough, because this is what this is. It's an embedded system, and Internet of IT, or the embedded systems, or IoT as they call it, is the future. We're going to have computers everywhere, and they're going to sense everything. And there's a real market for people to understand what's going on in an individual piece of hardware. Nothing is stopping manufacturers from making a cell phone the size of a wristwatch.
Yeah. What I really want to do is kind of like do a little bit of this, but on one of the newer Pixel devices. So like the Pixel 6 or Pixel 6 Pro with Google's own like custom tensor chip or whatever. They're running that's from like Samsung and customized by them. See what's going on there and see how it ticks.
Yeah, if you start getting in there and playing around with that stuff, and start blogging about it, you'll get a call. You'll get a call from Google.
Here's hoping.
Yeah.
But that's my presentation. Are there any questions or anything like that?
What was the hardest part on getting this going?
So for me, it was the process itself, like getting the software and then putting it all on the like that guide that I came up with,
Mm-hmm.
that just doing that. So like executing the commands, knowing what commands work on what device and what what specific way to do things on the device that would make it work properly, and then do the right things that I wanted it to do during the process in order to be able to get all the stuff on there and make sure that it worked in the end uh after doing it all.
That's your little write-up that you did. You should, I'm serious, you should put that on a blog post. Use your GitHub pages and use the static web page thing that you learned about Markdown and saying, this is what I'm doing with the Android. You'd be surprised, you know, other people are, hey, what are you doing? How are you doing this? Yeah. Go for it.
I unfortunately didn't record any of my like steps when I was actually doing it, so it would help if I had more of that. Like,
Well, even writing it out so you don't
Yeah.
forget it is, you know, worth its weight in gold.
yeah,
Very nice. Good job.
thanks.
I'm duly impressed. All right, folks, who's next? I see. Who else wants to jump in? Just start. Oh, there we go. Okay.
Hello, can you guys hear me?
Yes.
Okay. Oops, I'm at the very end. All right, so my name is Alejandro, and I created my project's based off of just remotely turning on your PC from anywhere in the world. It was pretty challenging at first, but I got through it. So let's go ahead and get started. So I'm assuming that most of you guys know what Arduino is already. Microcontroller, open source, runs off of C++, and it can read inputs and light on, you know, different functions depending on what you connect to the Arduino board. Yeah, so that's pretty much that. And so what I did, actually, I purchased a MKR 1010 and an IoT carrier. Basically, what the IoT carrier does, it has a lot of extra gadgets on it, so you can use with the MKR 1010 Arduino, and it basically attaches on top of the the carrier. So for example, so what I had to do is I had to grab a front panel to any desktop out there, just to use desktop that I didn't use anymore. And I created a bridge from the power button of the front panel of any PC. And basically I connected that to the relay of the carrier. And then the MKR attaches right on top, just right here. And with that power button, the cables run to the front panel of whichever PC I want to turn on. The power switch on a standard Intel front panel from motherboard, and the ground as well. So that runs from the power button of a front panel to the motherboard on the PC. And there's a bridge I created to the relay here on the carrier, which, like I said, connects to the MKR 1010 up here. I don't have a picture of it up here connected to it, but basically the Arduino is right on top. And so that connects through Wi-Fi on the initial setup. I set it up on the IoT page for the Arduino. I'll show you guys that in a little bit. And so it works off of widgets and variables that you can create to, you know, perform specific functions, input and outputs. And yeah, and then the carrier actually has it has two relays. It has where you can insert a 18650 battery right here, so you can have it, you know, powered on anytime, you know, remotely, I mean mobile pretty much. And these connectors right here, you can connect like a motion, what is it called, a moisture sensor. You can connect a actual like light sensor and other devices that they sell for this carrier. So let me go ahead and go to the next one. So this is what the IoT cloud site looks like. it basically has different categories where you can set up your device, how to set up properly. On this example picture up here above, we have the setup page, and where I have my Arduino connected. It detects it as being online because I have my network credentials inputted correctly, and so it's connected to my local area network, and it sees that. So the Arduino carrier with the MKR 1010, it basically creates a tunnel to the IoT cloud. I don't know what specific protocol they use for that to do that, or basically to have a secure connection. But this is how it looks on the top, and there's a tab for my variables, and I created a variable called the bool power, the bool variable, true or false, for the power button that I'm going to show you guys, which in this second. Oops, sorry about that. Went a little too far there. So there's the power button in this picture right here, right down here, and that's on the I believe the dashboard section, and that's where you can create a widget, basically a power button. There's a lot of other functions you can do as well. And down below here, we have a tab for devices where it basically just shows your device, and it also shows what if it's linked to a variable, which this power button right here is linked to this variable up here, the bool power variable. So it's going to perform a turn on and turn off function. Basically, input and output. Let's go to the next slide. And this is what it looks like when it's in action, basically. I have a mess, but yeah.
Yeah, it's pretty cool.
So it's turning off. Turning on and turning off right there.
That's pretty cool. Now,
So go ahead. Sorry.
I was just going to say, I put rport.io. That is a website that allows you to do IoT type control. Their protocols are actually beneath SSH and VPN. And it looks like your IoT cloud and your credentials works at a lower level, like a MAC address, and creates a tunnel between you and the cloud piece. That's
I see.
Yeah, that's pretty interesting.
Yeah, I haven't looked into it further. I was wondering myself like how it works, how it knows to point to the IoT cloud website.
Yeah.
So the server, basically, I was like confused about it, but I haven't looked into it further.
Yeah. That's some pretty interesting stuff, because there's things called like SSH jump proxies or proxy jump, that if you have a machine in the cloud, you SSH to that machine, and then there's a tunnel used by auto SSH to connect to your cloud machine that allows you to jump around and connect to machines on the other side of the planet. Yeah, there's a lot of trippy stuff going on right now with this IoT.
Yeah,
Very
that's
interesting.
that this device made it easy for me, because the Arduino developers and the people that run the website, they pretty much included the device, and it like just works how it is when you buy it. It works from the gate. So it's not like I set everything up by myself, which it would be a way longer project.
Yeah,
it'd be a lot more interesting as well. But essentially, I have the carrier right here. It has an LCD display on it. It also has touch buttons on it as well. So I would like to try to get this to show the ambient temperature of the case if I were to have it inside the case, positioned correctly. Or maybe read, just read, have a different function for it. But temperature would be the only thing I could see from using that LCD for me. But yeah, this is the front panel that I have down below, and I have a bridge and that connected there. It's a mess, but so that was my example right there for that.
because I can
go
see
ahead.
this. You could use this for your garage.
Yeah,
Automatic pet feeder.
yeah, there's a lot of things you can do. Yeah, so oops, okay. So the purposes for this, in my opinion, what I thought was, like, obviously you could turn on the PC from anywhere in the world. with the IoT remote app. It's called, let's see, it's called the IoT remote app. Pretty much, you just log in with your IoT credentials, and it'll show you your dashboard like I showed you guys in the previous pictures. It'll show your widgets, so you can just push the button like right there, like I showed you in the video. Like essentially, if your freaking documents at home, they're stored on your hard drive. I see the purpose for that. They're not stored on the cloud, somewhere like on Google Drive or whatever cloud service you want to use. If you forgot to put something on there or synchronize onto the cloud, you can always turn on your PC and access a remote control from from your phone or a laptop or somewhere at another location through TeamViewer, LogMeIn, Splashtop, you name it, whatever remote software you prefer. Chrome as well, Chrome remote control software, that's a good one. And it eliminates the need for Wake on LAN. I actually never tested a Wake on LAN before, Magic Packets to turn on my hardware. I heard it was like a hit or miss from a lot of people, but I've actually never tested it. So I figured that'd eliminate that purpose for that. And also, if you use like last Tuesday, where I forgot his name, but where he had like a Plex server on his desktop or on his and he uses the NAS, you could always access your files from anywhere, as long as you turn on your PC. The whole purpose of this is just to remotely turn on your PC yourself, or you can, if no one's home, or you could if you had someone home, you could tell them, hey, just turn on my PC, right? But that's not what we want. You want to have it. So let's see here. So my milestones were like, I learned how to use Arduino for the first time, which was interesting. I know a lot of people like Raspberry Pi. I liked Arduino. I don't know why, it just caught my attention, especially because that device made it easy for me where I didn't have to attach relays and stuff, which I need. That's actually something I should do, like by myself. But that device makes it simple and easy for people that want to just go straight to the coding or create a project. It has all the gadgets and widgets you need. So to create what you want to do on the cloud, something cloud-based. So I learned a little bit about that and the functions thanks to the Opla IoT team, the Arduino tutorials online on their website. Learned a little bit about how the cloud works with the devices. Successes, I learned how a relay works. I did not understand. I've never messed with relays ever. That relays, they're in a lot of electronic components, and they have, with a lot of, sometimes these electronic components are attached to like network devices. And so yeah, that's something I learned. I was quite confused because I'm not really a electronics type of person, but that's something cool. I thought, well, what's a relay and how it works? And there's a lot of other things out there I could learn as well from electronics. I learned about the different components of the IoT carrier. So it has like most people will do is just put the relays and build them on themselves on the PCB on, I forgot what you call those, but those boards with all the wirings. You can, but this comes all together. Just like I said, it makes it easier, but understood that you can connect so many different kinds of devices that have different functions to, like Arduino. And I learned it how to use it in a sketch. So essentially that website, it creates a sketch with your Wi-Fi credentials, and from there you can it basically updates the Arduino as long as it's online and connected to your Wi-Fi, and it keeps basically keeps updating it, checks it to update it or not, if something has changed. And in that sketch, you can basically create any statements you want in C++ to, basically just, create whatever you want in your own world, right? So with these in the sketch. So in my sketch, I don't show it in my project, but I basically just created an if statement to turn on the power widget, that button that I showed you guys on the dashboard and that I used on my phone. Basically, that sends the information to the cloud sends it directly to my device. Since my device is connected, like I said, I don't really know how that works, but so that's something cool. I just started off with the if statement for the relay. So failures and things I learned, I was like, well, there's so much more to the IoT carrier than just using one little piece of it, the relay. There's a temp sensor on there. There's a motion sensor on there. There's something I could try is like maybe on my phone when I open up the app, I turn on my PC. That's cool, but do I know if it's actually turned on physically? I need to find a way to have a status updated if my PC is actually on, beside, to show me on my dashboard instead of me remotely trying to log in. Oh yeah, it's on, but like, what if I can create a widget that shows that it's actually on? But I would have to look into that further. So yeah, brainstorm more ideas and how do I want to approach these tasks in a timely manner. What would I've done differently? Spend more time learning how to code, because I spent a lot of time not coding. It's not my biggest thing. I encourage people to try it, at least try it, because that's really what the world's heading to nowadays. And people, at least a little bit of knowledge on it will help you out in your career some way or another. Study circuitry and electronics and more, and to achieve more. So that's actually a good thing. I mean, because obviously, like, technology revolves around electronics, so it's good to learn both worlds, and try to understand it more instead of having something like just use something that's already built for you. Seek out more resources, tools, and help. That's something that I learned being out in the field. At my job, we always have to seek out for help, resources, wikis, and tutorials, that kind of stuff, or just asking a team member, hey, have you tried this out? Or, can I borrow your script? Does your script work? Does it work on this? That kind of stuff. That's something that I do at my job currently. I always seek out for help as much as I can, but I did not do it as much when I did this project. I should have done that. But fourth, maybe work in a team environment, because you never know, you could always achieve more with more people, different ideas, different knowledge, different ways to approach things. And that's pretty much, that ends my project. Any questions, guys?
How much did that board cost?
Oh, so that cost $100. It came with the Arduino and that carrier board together. Oh, with the 12-month subscription to the cloud service. It basically gives you more functionality, more as far as like how many things many widgets you can do, or I think there's a couple other reasons why, but you know how that works, those subscription services.
Yeah. I'm putting a thing in the chat,
Mm-hmm.
3rd edition. This put together by Charles Platt. It's a make electronics. It's everything you just asked about. This is a phenomenal little book that takes you through 0 to hero on understanding schematics, transistors, diodes, where they're used, how they're used, and you build little circuits as you go. It's very well done. And I was impressed when I stumbled in, because I started off in this. I know that side of the world really well.
Mm-hmm.
And when I saw this book, I go, oh man, this is very well done. I was impressed. So this, if you're interested in what hardware components, let's say I want to create something that flashes at 40 hertz.
Mm-hmm.
There's circuits in there to help you figure that out. How do you design your circuit? How do you design your filter to do a high pass filter, low pass filter? All in there. Very good stuff.
Cool. I'll make sure to add that to my OneNote.
You
Keep
bet.
that in the future.
All right.
Yeah, that would be cool, Anthony Castillo, about the UPS for battery monitoring. That'd be also a good idea as well. Play Doom on that mini display. Yeah, you could actually add people have done, like, in the display and the LCD, that they've actually created a video game, kind of like ping pong, like how Eduardo did. Kempa with his partner, they kind of created a video game on just that little display, which is pretty cool. I've seen it before. It looks very complex, time consuming as well. But yeah, that's pretty sums up my project for the class.
Very nice, very nice. Because that's going to take you, if you're interested in this hardware IoT stuff, there's going to be a big market there.
Right. Yeah, so I'll go ahead and stop my screen so the next person can go.
Okay.
And yes, Eduardo, I will use it every day if I continue working on it.
You
Thank you,
bet.
guys.
All right, who wants to jump in?
Hello, can you guys hear me?
Yes.
Okay, can you guys see my screen?
Yeah.
Okay. So for my final project, I'm not gonna take too long just because I'm nervous and I'm presenting, but it was a little last minute, but not too much, but it was a lot of learning and videos and everything which comes along that. But mine was, we created a chess game within using Python, using the PyCharm and importing the Pygame. And so breaking it down, I had to create an 8x8 chessboard with the black and white pieces, and then you have to implement all their specific moves for anyone that hasn't played chess before. There's a king, queen, there's the knight, there's castle, and the pawns, and they each have individual moves that they can do. And so learning how to write the specific coding for their moves without generating errors, or when the pieces would I guess say attack or take another piece, removing that piece from the board or just moving along the board. But it was a fun process, a lot of learning. I got it up and running for the most part. There's still some, little more things I want to implement, but I'll do a show of the program and show some of the code and then run it a little bit.
En passant. Oh yeah, right. Good luck.
Oh, no, I did not. That was that's on the task list, actually. I know exactly what you're talking about too. So
Yeah.
So here's let's go look at the board. It's just an 8x8 board, and the B's represent black, the W represents the white, two characters, the king, queen, rook, and so I was able to get it up and running. YouTube was my best friend. This is, I want to say, a common project, but watching about 20 hours of the videos and learning everything and debugging and everything. The main thing, just little accomplishments, just displaying the board and displaying the pieces, felt great. And then on to the next step, and just breaking everything down piece by piece, rule by rule. And so let's do a little presentation of the program. Okay, so we have the black chess pieces and the white ones. Generally in chess, I believe the white goes first.
Correct.
And so you can either go with the knight, and the knight's movement is an L. Just think of it as an L. There's 3 steps and then either one to the right or one to the left. And so let's say I click on it. It will show I have the spaces highlighted where it can go specifically. The movements of cable. So if I click, right here, it's not going to move there. It's not a valid move under the get valid move. And so let's look at the pawn, and it's able to move 2 spaces on its first turn, or you can just choose 1 space. And so let's do a couple turns and get the pawn moving. And now it's and now since I went, it's no longer white's turn. It's showing where I'm clicking and everything on the board. And say it's black's turn. and it'll let you know, okay, this is where this piece can move. And so I'll move it forward. And now I'm gonna see if I can take that pawn, because pawns attack directionally at a diagonal space. I can choose to go forward, or I can choose to take the black pawn. And so we'll take the black pawn. And now one of the other movements was the queen. And the queen's movement the queen's movement was easy once I did the castle and the bishop, because all I did was use the bishop and the castle's moves, because it does everything that a castle and bishop can do together. And so the hard part is the check and checkmate, and having the game, understanding not putting yourself into check and not putting yourself into check. And I'm gonna see if I can do that real quick. And see, these are all the moves for the queen. It can go, sideways, diagonal, back, pretty much almost the whole chessboard, as long as there's not a piece interfering with it or blocking it. So we'll take that, move this queen up, and say I wanted to move the king to right here, and it won't let me. And kings are able to move one space within each other, but it won't let me because it would be placing itself in check. So the object of a chess game is you take the opposing team's king, and it's writing that down. There was a video that really helped me understanding it and implement it and finally getting it to run after a couple hours and rewatching, and and so since I can't place the king within check, you would have to look for another valid move, and it could be something as simple as another L, moving the knight in front. And so I'll move my queen to take the knight, and now there is a valid move for the king, because the king can take the queen. It's no longer putting itself in check if it's removing it. But this should be the only move able to go right now, because I'm in check by the white queen. And so the only way to get out of check is to put something in front, which I can't. It's in one space, is to remove the white queen. And it's either with the king or the bishop. And the bishop takes it. But for the most part, I was able to get it up and running to this point. Once it gets to checkmate, I don't have that. I don't have that implemented all the way in. It was just mainly getting the pieces together and the movements and everything. And then that is kind of what I'm working on right now, is implementing a checkmate, and then maybe doing some type of animation and a reset button just to reset the board right over again. But throughout this project, learning Python was fun again. I still have a lot to learn. There's still some stuff I don't understand within it, but with practice I'll learn it more. But I had fun. Unfinished tasks, or stuff I kind of wanted to finish on was completing or finishing the game, and then making an in-game scene or animation just to say checkmate and have it pop up or something, and then implementing an AI to play against within the game.
That
And so-
would be doing the AI for chess has been a area for study for many, many decades. And if you want to learn about matrix calculation,
Right.
and brute force, chess is a perfect model to actually learn how to do all that stuff, because you can put all your moves into a 3D matrix.
There's so many.
Oh, it's phenomenal.
I had a lot of fun doing this. And so implementing AI, I think maybe I'd start out with just a random move generator for the AI before actually some type of logic between the moves and everything. But baby steps first.
Yeah, you betcha.
So
That's
what I learned is bad time management and being a procrastinator is a terrible combination to have. But it puts pressure, maybe unnecessary pressure, but pressure, and I'm able to work a little bit more under pressure because it gets closer and closer to the due date, and I need to get on top of it.
Yeah.
And so I have a lot to learn, whether it's coding, whether it's anything in the computer field, but it's so broad that one of the main thing is I want to know what I'm more interested in computers, whether it's just the network software or the coding, the games, or a lot of the projects earlier piqued my interest, but I'm not sure what direction I want to go.
You don't really have to decide. You just get a job and you find out what you hate, what you like, and you end
Right.
up where you are.
Right.
You just kind of experiment. And because one of the students I had many years ago is now a worldwide consultant in security.
Oh,
And
wow.
at the time, he was interested in robotics and motors, and he discovered this exploit in the Samsung phone, how to exploit Samsung Pay.
Right.
And he demonstrated it, and he showed it off at DEF CON. And from there, man, he got sucked into security big time. So
yeah, it was nice, the nice push in that direction, and and he found out what he liked. So
yeah, you just never know.
So I'm hoping for career opportunity after this degree and everything, and we'll see where it goes.
That's right.
And maybe I'll find something I won't like, or it'll be something I do like. So
yeah, exactly.
So that was my project.
Was it hard to get the PY game to work?
Oh God, it was it was pretty hard.
Yeah,
and then I watched video, and it's simple. People make it look real simple, and you feel a certain way about it. Like, yeah, I should have known that, but it was it was very hard.
Yeah, I've had the same problem with PY game. There's so many dependencies, and it's like version specific dependencies.
Yeah.
It's like, oh, what a headache.
So it was a headache, but it was a fun headache. We'll put it that way.
Yeah, you learned a lot. Oh my goodness.
That's all for me today. Any questions?
Very good, Jordan. I like the sound when it clicked.
Right.
That was nice. All right. Good job.
Thank you.
All right. Who's next? I know there's a few more.
And am I just sending the PowerPoint or?
Yeah, you can just post your PowerPoint because I have the video.
Yeah.
And then that the PowerPoint will help jog my memory.
Okay.
All right.
I'm happy to go next if that's okay.
Yeah, fire away.
Okay. So I did my project on an Arduino kit, and I chose to do the ultrasonic rangefinder. And what that does is you can measure distances, or you can take a measurement of a distance using sound waves. And so I kind of already went into it, but the sensor transmits a sound wave and it hits an object, and then it bounces off the object towards the sensor. And the sensor records, it keeps a timestamp of when it shoots off the sound wave, and then when it receives it, and it's able to calculate the distance and the speed of sound. Just a quick note is 331.29 meters. which and that is at 32 degrees Fahrenheit because the temperature and the humidity changes. It adds resistance to the speed of sound and as well as the speed of light. So why is this important? What industries does it affect? It's used, maybe not the ultrasonic sensor, but the concept of measuring. NASA has used it. It's a big tool used in geographic information systems or GIS. It's also used in the fishing and outdoor industry, land surveying and geomatics, engineering and computer science. And basically the sensor collects data, and that data or measurements is able to be used for drafting, mapping, GIS databases, and then as well as construction. So how it works is kind of a little diagram, but it shows the sensor. It has a transducer and a receiver, and it's got 4 pins. One of the pins receives 5 volts from the Arduino, and it also has one of the pins is the ground, and then there's the trig and echo. The trig pin is the trigger pin. It sends off somehow it sends off the waves, and then the echo is attached to the receiver. And there's a little diagram. It shows the transmitter sending the off the sound waves, hits the object, reflects back. And what can affect accurate readings? So with engineering, you want to take accurate measurements, and when you're designing buildings and stuff, and things to take into account for, they do have different like humidity sensors and temperature sensors that can help make sure your measurements are accurate. But so external sound waves coming from other things, large amounts of wind, the temperature, and then also if you're sending off a sound wave and you're wanting to measure an object at a certain distance, and if something else crosses between the sensor and the object which you are wanting to measure, it'll block the sound waves and it'll give you a short reading. So like if you're sending a laser or a sound wave across the street and then the car drives by, your laser or whatever will hit the car before it reaches the actual object on the other side of the road. So you have to just look out for that, be aware of your surroundings. I already went into the pins. There's a transducer and the receiver. The purpose of a transducer, it converts a mechanical force into an electrical signal, which that can be read. And the transmitter sends out 8 sound waves at 40 kilohertz, and then it stops, and then it waits to receive the sound waves, and then once it receives them, displays it on the screen, then it'll repeat the cycle. Here's just some images of the technology that is used today. There's something similar that I found online. it's not, it doesn't use sound waves, but it's called an EDM. It's a electronic distant meter. And that's used for engineering and construction. And they're able to lay out like building corners and stuff from what I've seen in the videos I've watched. They also can use GPS. And then also some of the newest technology that's been coming out within the past couple years is the using a LiDAR scanning and putting that on a drone. You're able to take measurements with a drone and get like a topographic a view of the land, and that's also able to be uploaded into GIS databases and used for future references. An example of sound waves actually being used is fish finders. What it does is on boats, they have a transducer that's mounted underneath a boat, and it'll send off readings, sends off the sound waves, bounces back, and you can get a digital view of what's underneath the water. A little bit of history behind it. Using from 1996, using a laser from the McDonald laboratory. They sent a laser and shot a reflector that was on the moon, and that was, I think, the first recorded distance from Earth to the moon. And NASA ran that project, and it's not, from what I found online, it says 238,900 miles, but that's pretty, I know it's not I'm pretty sure that's a rounded measurement. That's not exact. Some of my milestones, I learned how to read wiring diagrams. I was able to put various digital components together. I downloaded code onto a Arduino for the first time, and I got to interact and see how code works with hardware, and gained a new understanding of electronics. And I will give a presentation on it in a minute, but some of the lessons that I learned, and some of the failures that I encountered while doing the project. I tried to take on the whole project at once and try to add different components. And I realized that it was just easier to scale back and just to get get the bare bones working. And then you can also make changes later. And so just kind of do it in, connect the components in bite sizes. So that's my PowerPoint. And then I do have it all set up. Let's see here. So I don't know if you guys can see, but this is on my screen, my computer screen. It's taking measurements and it's saying 2 inches and 6 centimeters. And I do have the project set up right here. I have my Arduino connected to my computer, my breadboard, and here's the sensor. And then I do have a tape measure, and I have my handy dandy Rubik's Cube. And as I move the Rubik's Cube back further, it's taking the measurement, and on the screen, it's showing 21 centimeters. And my tape measure, it's inches and centimeters, and it's showing 8 inches and 20 centimeters, and on the screen it's showing 21. So it's pretty accurate. It gives you a result like within a centimeter. I tested out the max distance that it would read, and it'll give you an accurate reading at 9 feet, which was 108 centimeters, or I'm sorry, 108 inches. And then after that, I tried, it wouldn't take a reading at all after that. I tried using bigger objects to see if it would help. But it was able to get within a centimeter or within an inch using just a Rubik's Cube. And that's only about 2.5 to 3 inches tall. So it was pretty accurate, and I was pretty impressed with it. So any questions?
What was the cost of the sensor that you used?
The whole kit, it was about like $65, but I think the actual sensor itself, I think it was like $3.
Okay.
Yeah.
Yeah, that would probably explain some of your precision issues.
Yes, absolutely.
'Cause
So
I know they use some of that stuff for land surveying. So they get it down to like, millimeters.
mhm. Yeah, so that would definitely explain why.
Yeah, no kidding.
$3. So you get what you pay for, right?
Yeah.
So, all righty.
Very
yeah.
good.
Well, thank you. So
Very good. Any other questions? Okay. All right, let's continue on. Who's left? I know of one or two. All right,
Is it showing my screen?
okay.
Okay. So if it will load. Oh. I did a project in Unity. I named it Cube Run. Cube Run is a third-person arcade game with the main goal basically being to maneuver through obstacles until you reach the end and then kind of go to the next level. It's pretty quick. I think I only have like 2 levels, but I wanted to be fast. And then the milestones I had for this, basically learning how to use Unity, which I didn't know anything about, and then also creating scripts for it to make the character move or the box, however you want to name it, and then fixing them to make the game function as intended, and then working in that 3D space. Also learning how to set a good pace because I am not the exact best at that either. And then successes, I got Unity work, got the game working to do what it needed to do, which I was like, oh, that's cool. And then definitely having more confidence in creating another game in the future or just kind of working on this game. And then failures. I tried a 2D game before this. Didn't exactly work out for me because I had to crop or tried cropping some of the assets out and I was just having problems with it. So I was like, oh, I'll try 3D. And then obviously file management. I had a few times where I accidentally deleted things and misplaced things or misplaced the files, and it was rough times.
Yeah, this is a problem that I've seen over and over again.
Yeah.
Yeah, it's the way it is.
So I had a few times where I had to either restart the project or just like find it. And I think that's also one of the reasons why I stopped doing the 2D, because there were so many assets to kind of like keep track of. And then obviously the planning out of the code and just I kept trying to do the code before actually understanding what it is I'm trying to do. So a lot of times it came out biting me in the butt because I didn't know what exactly was going on. And then obviously making better comments. So then if I were to do this in the future, people could look at the code and be like, okay, what is going on?
Yeah.
And then implementing features into this game that I didn't have time to exactly do. Oops. And what I do differently, basically plan and learn first before actually acting, because that bites me in the butt a lot. Setting a realistic and achievable goal, which I think I did a pretty good job at doing this for the game, given it's still kind of raw bones, but at least it works. And then spending more time learning C# because I had no experience beforehand. So this was like a first time on Unity and C#. And then potentially even going back to the 2D concept and seeing if I can make it work there. And let's see if I can go to, do you guys see the cube run, or is it only on the, what's it called? PowerPoint.
Yeah, we
See
see the
slides. Okay,
PowerPoint.
let me see if it will bring up my project. Is it showing up or is it still? Oh, sure.
There we
Is it?
go.
Okay. And then I will maximize on play. We play game. And then cute little start button. And then when you knock into something, it stops and it resets. Basically, what I have is 2 levels. It goes into the next one after this. I still cute completes. And I want to make it short because I didn't know how much time I had. And then there's thanks for playing. And usually quitting here would end it.
That's good. It gives you that feeling. Imagine the goggles, and it gives you the feeling of vertigo. You could have some fun with that.
And that's kind of the end of it. Is there any questions on the game or whatnot?
That was pretty spiffy. On the when you did the Unity, you're developing this on Windows?
Yes.
Okay.
What I did was go for the scripts. I did Visual Studio Code because a
Okay.
lot of the places are kind of the sources I went to were, oh, you could just do Visual Studio Code. So I'm like, okay, I'll try.
Yeah, there you go.
For adding, what I would probably do is add sound, because obviously when the block bumps into something, it doesn't like do a little oof or like, oh, you actually hit it. So sometimes if you nick, it just restarts and goes back after a certain time. So having that type of sound, so then the player knows that, oh, you actually hit something, or even kind of like a pause menu, because obviously it was going so fast from level 1 to level 2. It's like, oh, okay, maybe the player needs a pause, as well as many other things too that I probably want to go into later.
Yeah, you're gonna continue tinkering with this?
Yes, I have another level that I was probably going to try changing the platforms. So you saw how it was like a white platform for this one. Let's see if I could go just to how there's like a platform here. I wanted to try to change the platform so then it's different. It maybe even changes direction. So then the player has more to deal with. I think about making the plane that keeps it on the tube and you spin around the tube. Maybe I will see how it works, because another problem I had with this game was the camera, and sometimes the camera goes a little wonky. I had a really rough time with that camera because whenever I got off the edge, if it will show up, the camera would sometimes just spin, and it was not fun.
Okay.
Yes, it was rough. Luckily, it's just going forward, so it's not too bad. But once you start actually moving, I don't know how it's going to react. So that's something that's going to be fun to work with. Quotes on the fun.
There. Way cool.
Thank you.
Good job. Any more questions?
I will stop my share.
All right.
Oh, I had a question real quick.
Mhm.
Do you think you'll make like a temple run style game?
Potentially. I'll probably play with the background or just kind of the platform that the cube is on and see how that works. And if I could keep like improving on it, then maybe I might go that route. I also want to do the 2D game because I want to see how exactly the levels like load in and whatnot, and kind of work with that and see if I could implement them and they help each other in a sense, for like going from one
I
level
see.
to the next, or even just how you interact from a 2D game to 3D. So there's a lot of things to kind of work on.
Oh, I see.
Very good.
Thank you.
Who's next? All right. Gustav, you were supposed to go first tonight, but you came in late.
Hi,
Sorry.
Professor, can you hear me?
Yeah, I can hear you.
Yeah, sorry, I got up I got late out of work, so that's why.
No worries. You're here.
Okay, Okay,
And
so
as
our
moment.
yeah, so our project is based on a Windows server, and for this project, like we basically use Active Directory, and so we're using Windows 2016 server, and well, me and Mohammed Isaza did it together. So for this project, the resources I use was VMware Workstation Pro, Windows Server 2016, which is the Windows Server, and DHCP Server, Active Directory, and I use a different operating system, like for making a different user account. So I use Windows 11, Ubuntu, Debian, Windows 8, and Windows 10, like different operating system, and so like I did like I wrote like all the steps, like how I did it, how I created like my own network. So here's I wrote all the steps. So first thing I did was like to install the VMware. Then I downloaded the Windows 2016 server from Microsoft website, like the ISO image. And next step was to create the virtual machine for the server, and then like do all the configurations. And lastly, I boot the ISO and select the ISO image. So, and okay, so this is like the second step. Just like kind of like messed up. So in the second step, like I had a issue like with booting the Windows server. So I don't know why this is. Okay, so in this one, like the failure I had was like always pay attention to the error codes, because like whenever I would get this error, like I don't know if you guys see it, like at the bottom right corner. So we just click OK and like do read the message where it says so, and then keep troubleshooting like why it's not booting the server, why it's not booting. So eventually, like after reading the message, like I found like what was causing the server like from not booting, and then always okay, let me see. I had to deal with troubleshooting, like what was causing the failure during the boot process and when booting the server. So I would say like, lesson I learned was always make a plan first before acting. Before acting, don't make big changes all at once, and keep things organized. Configuring setting incorrectly will cause more problem, because I was like messing around like with different setting, which caused like so many errors. And always do research like before you start a project, like do some kind of research so you have like better understanding of it. And okay, let me see. And here's the error message. So in step 3, what I did was I tried to like to find like what was causing the issue. So after doing some online research and reading some knowledge-based question, I was able to find the symptom and the error. So I found out that if VMware workstation in 15.15 version or newer version is running on Windows host where Hyper-V or VBS is enabled, VMs will launch using Windows hypervisor platform technology, and VMs will fail to launch if the release version of this technology is not a particular level or the Windows host hardware does not meet certain minimum requirement. These requirements are described in the cause. Let me see. So after that, so after I found the solution, I tried to test the theory, like to make sure it's working, make sure like it's that's what's causing the problem from booting the server. So first thing I did was to verify the virtualization based on the VBS enable, like whether it's enabled or not enabled. And then next step what I did was like checking the MS Info 32 system information on Windows. And then I did like how I did was by clicking under system summary on the right hand page and all the way down to virtualizations, base security, and then ensure the Wally is set to not enable. So after checking if the Wally is set to enable, and then next step was to turn off the Hyper-V. And so first thing that's like here's the how like the steps to turn it off. And then I did like some other troubleshooting, like some commands that I ran in the command prompt. It was the BCD document that I found in Google, like that can turn off the hypervisor and to disable hypervisor. And also like whenever I would try to boot the Windows Server 2016 server, like my computer would keep restarting several times, but that didn't help like after running this command. And then the last step I did was turn off WireGuard, which was in the group policy. And after that, let's see. And after turn off the WireGuard and disabling the Hyper-V, and I was able to successfully run the Windows 2016 server. So then I created the operating system, and after that, let's see. So success, I had success that I had like in my project was connecting user to the domain account and accessing Windows Server share folder from Linux user account, and learning how to map a drive and make it available to other user. I gained a lot of hands-on experience managing servers and Active Directory. And here are some things that I would do differently. Always make a checklist for all the required things for the project. Set a clear-sighted and achievable goals for the project. Always do more research, learning before starting the project, and make a plan of action and keep things all in one place. Okay, let's see. And
Yeah, because you called me a little bit and asked some questions, and I said, "Oh, you're going to learn a lot," because you basically set up an entire domain and clients just like you would do in business. And wasn't part of you trying to learn how to do this for a family business as well?
Yeah, so I had like some experience with Active Directory because I took the A+ class, and the one was the I don't know, the other one it was the 223. So I had like a little bit of experience with Active Directory, but like I want to like get in like learn more about it and see how it works. So I will show you that later. Like once I finish the presentation, I will show you like what I have done in the Active Directory. So yeah, and the milestone. So I learned how to window. Let's see some mistakes here. Learn how to manage Active Directory, working with group policies, creating end user account, assigning group policy to user account, and giving user limited access to share folders and data, and configuring DHCP and DNS. Learn how to be a better troubleshooter when figuring out problem. Learn how to create your own domain. Learn how to connect user to a domain. So I had like an issue connecting to the domain because the problem was in the network adapter, I selected a bridge connection where I had like hard time like connecting those other hosts to the domain because it was using bridge connection, but I eventually like I figured out like I had to change the network adaptation to NAT. Like after that, like I was able to connect to my domain. So let me show you my. Let's see. Okay, so I created like a home domain for like my home, and I created like a shared folder like for just like an example like for remote support, like shipping department, just like for different department, and and for internet, I also added the DCP, which assign like IP addresses to every host. And here's my domain. I want to create it, and let me show you the actual directory. So here's all the like folder I created, like all the user account. Where is it? Like see this one, I just create like example like shipping department. I create like computer, which is Windows 10 client, and the user, which is down, and for down also. So I create like different folders, and then to each account, like I assign like a different group policies. So let me go to that group policies. Where is that? Okay, so here is one of the group policy that I assigned to one of the user, which is, let me see, things down. Yeah, so I don't know why it's not showing, but it's in the shipping department, which is this user. Let's see. So,
Yeah, all we see is the slides. We're not seeing the,
yeah. Oh, can you guys see it right now?
yeah, well, all we see is the slides.
Okay. Let's see. Okay, let's see. Okay, let me make it full screen. Okay, can you see right now?
No, all we see is the milestones page.
So let me stop my screen. Okay, let me share my screen again and see if it works. Can you see right now?
Yes.
Okay, so let me make it full screen. Okay, so here's the one of the policy that I assigned. It was the system clock, which is a, let's see, like right here. See, I turn off the system clock for this user, which is the Windows 10 client, which is under alias, which is my brother account. So I turn off the system clock, which you cannot see right here. So on this one, let me show an example. So this is a different user. So on this one, so you can see that system clock right here at the bottom, the right corner. So on this user, it doesn't have the system clock because I turned it off in the group policy. So here's the like some of the policy that I assigned to user each users, and yeah, and for because I also use other operating system like Ubuntu. So for Ubuntu, like from like the best I could do was like to access the Windows files, and that you can do like by going to locations and then typing SMB like this address, which is my domain IP address. So enter. It's trying to like connect to my domain, my Windows domain. No, it's not getting it. Okay, let me change IP 46. Okay, let's see. Okay, let me see the IP address. I had this issue before because for some reason the IP address of my domain like it would keep changing like once in a week. I don't know why it does that. But see if I can find the IP address. Okay, so 168.73.148. And now let's try. There we go. Mhm. And, and, no, why it's not working for some reason. So, so
Yeah.
I
Welcome
just
to,
forgot the login. I don't know.
yeah, welcome to the world of getting Ubuntu. I can tell you that the version 22 of the
No, remember I showed you like I was able to connect
yes,
to my
and
domain, but
we remembered you actually have to make sure that the domain that you called it is part of the username, right? Like username / domain name.
I think it was, let me see, it was administrator /
Yeah, something like that, or whatever the domain was, home or whatever.
yeah.
Domain, yeah.
Let me try that.
Yeah, I can't remember what we did. But yeah, I remember
I
getting
just
it
forgot.
working. Yeah, it's kind of a headache. This is all Samba, and the Samba does work, but it is really picky with Active Directory.
Yeah, I don't know what was the login, but I was able to see like all the Windows share,
Yeah.
like everything right here.
Yeah, the new version of Ubuntu 22 has NFS or NTFS built in, and it plays well with Active Directory a little better. So we're starting to see this great convergence of operating systems where everything works well together. But people aren't going to care because it's all going to be in the cloud.
Yeah.
So we'll see if the cloud takes root. But this was quite a undertaking for you. You learned a lot.
Yeah, so that's it from me. Yeah, I learned like a lot about like managing user account, assigning like different group policies.
Yeah.
So yeah, that really helped me a lot.
Yeah. Phenomenal. Now your brain is tired.
Yeah, like it's been a while because like I haven't looked up the project like for a couple of weeks because I go to work like 5 days a week. So
yeah,
like
yeah.
today I just like
And you
like,
forget
whenever
you forget those passwords you think you'll never forget. Yeah.
yeah, I did.
All right. So I think we have
Yeah.
a few more and we're way past our time. So let's go ahead and open it up to who's left. I see Lewis is left, and anybody else after Lewis? Jump in and say something. All right, so Lewis, fire away.
Hi. Can you guys hear me?
Yes, can hear you.
All right. So what I went ahead and did, so I have this Pi, and I pretty much made a server for this game, for me and my family to play, like a local. We can have our own world, and it's just for people in the household, and that's pretty much the gist of it. So what I went ahead and did is let me just pull it up here and I'll show everyone. So I have this Pi with this little screen here. I usually have it hardwired, but I have it wireless right now just for because I couldn't what's it called? I didn't have an Ethernet cable long enough for it. So pretty much what I did, I after numerous tutorials, I've always wanted to make my own Minecraft server, just for like personal use. I there's been so many cases where like for example, there's you could use like Hamachi to play with your friends via LAN. You can even purchase a realm, and from what I've done in the past, Hamachi works, but it doesn't always work. So obviously that's to play with your friends. Then there's also realms, and that's where you pay monthly to have a server pretty much hosted, and that's not free. So that's another reason why I didn't go that route. So I have a 12-year-old little brother, and he always enjoys playing Minecraft. So uh he with me, and what we pretty much did, we have my dad and I have another brother, and uh we play together on the same world, and pretty much this pie here hosts the world, and that's pretty much what we went ahead and did. I downloaded from the Minecraft website. There was a like a server.jar file, and you pretty much you set it up to run off of the pie pretty much. So just to let me switch to my screen here. If I could figure out how to even do that. Share screen. Sorry, this is a first for me. Where do you does anyone know where you share your desktop?
If you go to meeting settings, you should see, if you open the screen, there's a button at the bottom that says share screen. It's
yeah. Right in front of me.
Yeah.
Okay. So I haven't set it up yet to where I eventually I do want to add security to it, to where, and obviously open up a port to where I don't know, could you guys see that first off? So I want to open up a port and add some security to it, where obviously eventually I can have people that aren't on the local network join. Again, it's a work in progress. This project was very I would say last minute. So originally I had something else in mind, and I just kept switching back and forth. So I figured this should work fine. So here's the game. You pretty much launch it here, and on the Pi, you would pretty much run this terminal command to get the IP that you need to get into the server, and you put it in, you click join server, and then it's going to be the same address for anyone else on the same network trying to get into the world, and you can pretty much play. And the reason why, another reason why I wanted to do this is because while in the game you can actually host a LAN world, the only thing is this your computer, the one that you're hosting it on, is going to have to be on all the time, and that's another reason why I did it with the Pi, because I'm not always home and my computer's not always on. So there's going to be times, obviously as like a 12-year-old kid, you have way more free time to play. So I would pretty much for me, I have this Pi, and it's pretty much on every day, all day, and he just hops on it and plays it a lot more than I do, and that's pretty much why I wanted to do this more for like personal use. So for let me see here. So in terms of some successes and like the milestones here, so like I thought it was pretty cool how like you can have a Raspberry Pi act like as a little home server. It made me really think that there's so many other things that you can do with it, minus Minecraft servers, like maybe like a home media thing where you guys can share movies or whatever it may be. And then in terms of like some failures or lessons, so originally what we had set up, we had the world was modified to where it had this mod called a pixel mod, and what that is, it's like a Pokemon mod. Again, I did it for him just because he was into that stuff. And originally I had everybody that's on it has to have a certain has to have their game modded pretty much where they can play on a server that has it. And when I went to go ahead and did that, I was gonna modify the server files, the game files, so it can obviously it could be a pixel mod world, and I ended up corrupting it. So a big lesson that I learned here, because we did have more progress, would be to create backups of everything, create backups of your world, because you're if for any reason you start in this case modifying the game files, you can mess it up and corrupt it to the point where it's gone. And he was a little disappointed, but it's okay. You obviously Minecraft, you just start again. You really don't stop playing it, you just take breaks. And then in terms of like what I would have done differently throughout this thing, originally this wasn't going to be my project. I wanted to make a portable password manager. I wanted to make a bunch of things, but I think what you really don't want to change to a bunch of different projects. You kind of want to stick to one thing instead of like changing back and forth. That was an issue I had. I had like six different things that I wanted to do. And then you also don't want to bite off more than you can chew. You don't want to do anything that's like too hard, especially because you got to finish it in a course of a semester. And then you also want better time management. So that was pretty much, I know it was pretty lackluster, but again, I have this server. It runs off of the Pi, so it doesn't use up that much juice. It just sits in a corner, and I have it set up to where whenever you turn it on, it automatically boots the server up, and when you turn it off, the server goes off. And then that's pretty much was my project.
Yeah, I understand completely about backup. It's like restore from your previous backup. Backup? What's a backup?
Yeah.
And Minecraft is free on the Raspberry Pi. When you download Raspberry, there's a few pieces of software that you normally have to pay for that you get free. And that's another reason. So.
Yeah, well, we own the Java edition, so
yeah,
it's better. There's more features and stuff.
Oh yeah, of course. Very good. So I think we have one more, or am I incorrect in that? One more. Oh, here we go. We're going down here.
Oh, before real
yeah,
quick,
ask some questions. Yeah.
That question, how many people that I've had on it? I would say I've had 4 at once, which is just everyone that has a computer in my household. So, and it's worked fine. When I have it wireless like this, I have tried it, and it does tend to actually lag a little bit. But when it's hardwired, there's no problem at all. It runs fine with all 4 of us on it. And it's a 4 gigabyte Pi. Pi 4.
Awesome.
All right.
Very nice. I think we have one left, or do we have more after that? I think I saw one more after yours, Lewis. Yeah, here we go.
Okay, can you hear me?
Yeah, there we go.
Okay. All right, so my project is 2 major parts. I decided I wanted to learn how to web scrape, and then also how to build an interactive map using R.
Awesome.
So the first part of my project was the web scraper, which I made with JavaScript. And the second part is the map that I used R and a package called Shiny. which helps generate the HTML and the CSS needed to turn that map into kind of a web page. So the tools that I use for the web scraper, again, JavaScript, and then I also needed to install Node.js and then Axios and Cheerio. So for those of you who don't know, Node.js is a back-end runtime environment for JavaScript that executes code outside of a web browser. So this was really important for my project since I did execute the web scraping script using the command line. And Axios is a library that is used to make HTTP requests from Node.js in the browser. And then Cheerio is also another library for Node.js that allows you to parse HTML, and it provides an interface for iterating through the HTML code using a jQuery-like syntax. And then I also used Visual Studio Code to write the script, and then Google Chrome's inspect element feature just to figure out what the website looked like on the HTML side so that I could factor that into my code. And then Excel and Notepad just for troubleshooting the output that I made. And then for the map, I used R, and then the two most important packages that I used would be Shiny. Like I said, Shiny is a package for building interactive web applications that can change based on user input. And Leaflet is a package for R that allows you to make maps. I didn't know this when I started my project, but apparently JavaScript has a package named Leaflet that does the exact same thing. And then for my R code, I used the RStudio IDE. And then I also created a external CSS document to style my application further. So I'm just going to talk a little bit about the process for writing the web scraper and then also the map using R, and then I'll show you what the end product looked like. So the first step in my process was figuring out how to access the internet using JavaScript through the terminal. So that was made possible with Axios, which takes the string URL I write in JavaScript and sends an HTTP request to the server using that info. Cheerio then allows me to write code that will capture those little bits of Indeed's HTML and iterate through the tags. Afterwards, I assign the text within those tags to variables and save them as object properties. And this is just a look at what Indeed's HTML looks like. So as you can see down here, when I go on Google Chrome and I inspect elements on Indeed, you can see that there are all of these HTML tags, and this one in particular, the span with the class of company name. Within my web scraping code, I used Cheerio's find function to look for a span with the class of company name that's also within a div. And then I extract the text and save it in a variable called company. And I do the same thing for stuff like the title and the location of the job and pay and description. So this part just loops forever if I let it, but in my code, I set a hard value for how many different jobs I wanted to scrape. So it keeps doing that until it's told to stop by the script, and it jumps through each page, scraping the same information. So all of the information that I scrape from each job is stored in an object that I assign to the class job. And then I push those objects to an array and then output everything as strings separated by commas so that they're easily formatted into a CSV. So the output looks like this. It's basically just this header row that has title, industry, company, city, state, zip code, pay low, which is for any jobs. If you ever look on Indeed, they might say from $3,000 a month or something like that, or a range of value. So the pay low takes the lowest pay amount and pay high takes the highest pay, and then pay type stores whether or not Indeed has it listed as hourly, monthly, or yearly. And then also the description, so any information pertaining to that particular job. Afterwards, I just import that CSV into R and join it with another spreadsheet that includes latitude and longitude coordinates for every city in the United States. I then used Leaflet to create the map widget that you can see here. So Leaflet creates everything inside this box using the information that I have in the spreadsheets. And then I use Shiny to create the reactive function so that if you see here, you can change some of the output on the map. So you can select a state, select an industry, and then you can update and see that reflected within the map. And then after I do all that, I make a few changes to the design of the application using CSS. And I think, yeah, so right now I'll just go and show you what that application looks like. Can you see the this new page, or is it still showing the slideshow?
It's still the slideshow.
Okay, let me see. Okay, now can you see the new?
Yes. You
Okay,
see
cool.
VS Code or R Studio.
Our studio, okay, yeah. So I'll just go and run the app. Okay, and you can see right here from the slideshow, this is the map. And you can click around and zoom.
Oh, it's still showing the R Studio.
Oh, is it?
Yeah, it's not showing the browser.
Okay, dang. All right. Let's see. Let me just go to screen. I think that'll work better.
Yeah.
Okay. Now can you see it? Okay.
Yeah.
All right. So when it opens up, it starts from this view. So it's really zoomed out when it starts. It has a navigation bar up in the top where you can go between the actual map view, and then you can also view all of the data that goes into the map. And then I have a few other links that don't work quite yet. So there's nothing here, but back on this page, the map, you can zoom in and pan around and you can see all of the different data points that were pulled from Indeed. So if you click on any of these blue dots, you'll see the information about the job title and the company, and then also the pay. Anything that didn't have a pay listed on Indeed just says 0 right now. And there's a lot of those. You can zoom in really closely. And then anything that has a number like this 9 or this 6, those are just clustered. So it's anything that's in the same city. I was able to scrape about 3,000 jobs from Indeed before getting blocked because I didn't know that would happen when I started, but apparently they do limit how many HTML requests you can make to their webpage in a certain amount of time. So this happened a few times. But so over here on the left pane, I have just a few summary statistics about anything that you can see in this window. So currently, you can see 1,043 jobs. The median salary for those jobs is listed here, and then the highest paying city in the current view is also listed. But if you zoom in or pan around, that changes. And you can also filter based on the industry that the job is listed under. So for instance, I can look at healthcare in California that pays 65,000 to 94,000. That may or may not return anything. It just depends. Yeah. So there's nothing for that particular. Let's just take that out. Okay, and then it zooms into the area where those jobs are shown. So now we see healthcare jobs in California, and you can see there's only 5 because I haven't scraped that many jobs, but I was able to get some of them to show up on this map. And you can basically do the same thing for any of the other industries. And then the map updates.
How long did you work on this?
Well, I started web scraping, I think back in February. But once I started R, I think that might have been sometime in March. I'm not entirely sure, but I've worked on it most of the semester.
Yeah, it's got the glimmer of somebody, you've spent a lot of time on this.
It was really challenging and time consuming.
Yeah, this is, you have no idea, but this is a hot market right now. Anything related to GIS and graphics and like geographic information systems, where you're doing exactly what you're doing. Earnings by zip code, schools by zip code, anything can be mapped along those lines. There's a huge need for that right now. Like, for example, how many positive cases of COVID have we had since March? And you can actually drill down on maps that have that kind of data. Somebody has to put them together. And this is a crying need. This is a brag tag galore. Very good.
That's what I really liked about using R, was that you can take all those, you can take thousands of data points, maybe even hundreds of thousands or more, and you can just throw them in here.
And R is used heavily in medical statistics. You can actually go to school and major in medical statistics. It's basically an actuary for health insurance companies. It's growing like crazy. Really cool.
But yeah, so there are a few unfinished aspects to this, and there are a few bugs, obviously. Like I'm a perfectionist, so this bothers me a lot. This hovering zoom toggle right there, and then also my reset button doesn't do what you think it would exactly. It clears the fields, but it doesn't update the map. So that's something else I wanted to work on. And then also, if you look at this tab, there is a graph that shows up. This is just a histogram right now, a placeholder that shows how the salaries are dispersed. But one thing that I struggled a lot with this project was accessing the actual CSS used to design the web page, because like I said, Shiny, it's the package in R that kind of builds this interface, but a lot of the CSS that they use is hidden from me. So I can't actually inspect that until after I build the web page to make modifications. So yeah, that was a bit of a challenge.
Yeah, my goodness. You should be proud. This is quite the project.
It was definitely a lot of work.
Yeah. I'm impressed. This is gonna look really good.
Well, that's good to hear. Okay, so some of my successes and failures on this project, I did accomplish my original objective, which was just to, learn how web scraping works and to scrape something from the internet and then put that on a map. So I was able to do that. I also learned how to run JavaScript code outside of a web browser, which when I started the project, I didn't even realize that was something that I would need to know how to do until I actually sat down and I figured out that I couldn't actually do anything with JavaScript without an HTML document like I had always done in the past. So that was an interesting concept to learn. I also learned how to iterate through DOM nodes using Cheerio. I had to read a lot of the documentation online just to figure out what methods to use for that. And all of my code right now is on GitHub. So I learned how to manage a repository and update the project using GitHub, and then also clone my repository using PowerShell. I learned how to use Shiny and Leaflet and a few other packages that I didn't mention because they're not necessary, but they did help with cleaning the data and kind of analyzing it as I was working with it. And like I said, I learned how to learn using documentation on the internet, and then anything that I Google, I was on Stack Overflow quite a bit. Some of the failures, yeah, like I mentioned, I didn't understand how some of the packages were working under the hood, and it caused a few weird bugs to pop up in my project that I'm still not quite sure how to fix, because a lot of it is kind of hidden from me. So yeah, there's a few unresolved issues like broken buttons or hidden CSS. And then I never figured out if it's possible for me to scrape more information from websites like Indeed before getting blocked by them. So that might be an interesting thing to know for the future. And then also I did lose a little bit of data while working because I shifted my project between 2 different computers, and I needed to keep track of all of that, all of my directories, and sometimes stuff got lost in the process. Lessons I learned that being consistent, consistently working on my project more frequently helped me brainstorm new ideas and solve problems that I was having faster than if I took long breaks and didn't return to my code. I also learned that it's good to keep notes on all the web pages and everything that I find while starting to learn something new, and just keep them all in one place. For this project, it might have been a better idea for me to use a database instead of multiple CSVs, because it kind of got a little messy near the end as I was adding data, and a database might have just kept everything better organized. It also would have been a better idea to consult possible end users. In this case, that would be my family earlier in the design process, just to ask them what they think or if they have any ideas, because they did give me a few cool pointers. And then I also learned that this project in particular could be really overwhelming at times, and it might have been a good idea to work on a team just so that I would have, that extra input. So yeah, if I could do this project again, I would create a database to store all the records, and I would use a software development pattern probably to better structure my code, because it did become a lot after a while, just keeping track of everything and knowing where, like scrolling through my code in R, I would quickly lose track of which part held my HTML code and which part was the functions, because I just have one whole script for doing everything in R, and I probably shouldn't have done that in hindsight. I would probably use a web development workflow that includes PHP, and if I use the database method, and then I would work exclusively on one machine so that I don't lose anything like I did this time.
Yeah, my goodness, that was really good. I had a student that did something similar, and he's now working in New Zealand as a GIS manager. So you're on your way. Very nice.
Yeah, I learned a lot from this.
Yeah, I'll say that was phenomenal. Very good.
All right, so if anyone has any questions, I'm not sure if there were any, or else we can just go on to the next person.
So R was the first thing. This is the first time you touched R.
Actually, I worked with R a little bit at the end of last year, but most of what I did was just data cleaning, and then also making static, like really simple charts and graphs. So this is my first time using like R packages and creating anything with R that can actually be manipulated.
Yeah.
But I was really a beginner. I'm still a beginner in R.
Oh, yeah. Yeah. Very nice language. Very good.
All right. Okay, that's it for me. Thank you.
You bet. All right, I think we have one more. Maybe two more. So if it's your turn, jump in. It was a very nice project. All right, I think, who said they needed to go? Harvin? I think you're, at least you're on the chat. There we go.
Can you hear me?
Yeah, now I can.
All right. You'll have to forgive me a little. I'm currently fighting a cold right now.
Okay.
So my project was I made a kart racing game in Unity.
Okay.
And well, originally I was going to make a 2D game, but that got scrapped like pretty much right away. So instead I started making a 3D game, and at the end of March I got the idea to make it a kart racing game. So in April, at the beginning of April, I downloaded the kart racing template from Unity, and I learned how to use it to make a kart racing game. And then April 2nd, I downloaded some model packs from the internet so I could use them in my kart racing game. And then all of April, I pretty much spent like, I'd say a few hours every day working on the game just to get it into an okay state to show off. But there were a few hiccups. Like there was a week where I had to slow progress down to work on stuff for my other classes. And yesterday and today, I'm fighting a cold right now. So progress had to slow down for that too. My milestones for this project I achieved. I learned how to use the Unity editor. I learned how to use Visual Studio with Unity. I knew how to use C# in Visual Studio before, but this project I learned how to use it with Unity. And I also learned how to work in a 3D game space. My successes, I made a kart racing game with about 9 levels that are playable, but they're not fully completed. They're just playable right now. And I learned how to use Unity to make a 3D game. My failure points is because I started working on this so late into the semester, none of the levels are really completed. They're just all playable right now. And most of the code I've written doesn't have any comments in it, which isn't really the best practice. I would prefer to go back and add a lot of comments to the code so I know what I've written before. What I would do differently now that I've finished, or now that the semester's over, what I would do differently is have better time management and start working on the project sooner rather than later in order to have the time to achieve everything that I want to achieve with the project. After this semester, I'll probably continue working on this project a bit more and have the levels be in a more completed state, and probably also have some more levels added overall. And let's see if I can bring up Unity real quick. Can you see Unity?
Yes, we see Kart Racer 101.
Oh yeah, that I couldn't come up with a very good title, so that was just what I went with.
That works.
So this is the game that I made. I'll show a few levels just to show you what the game looks like. So this is the first level I made. Probably the most completed looking level. So since the Unity has a car racing template, a lot of the scripts were like already provided by Unity. So all I really had to do is add scripts to like control how the game keeps track of laps and your time remaining. And if you're going the right way around the track, there's like invisible checkpoints on the course just to keep track of if you're going the right way around the track. And when you go under the gate here at the end, it counts a lap if you passed all the checkpoints in the right order.
And some of these assets you found on the internet, like this cart.
Actually,
itself.
the funny thing is, this game is inspired by Mario Kart.
Okay.
I was just like thinking, I was playing Mario Kart one day and it had just inspired me to make a kart racing game in Unity. So that's how I came up with the idea for this project.
Nice. I like how the shadow, is that part of the asset where the shadow came in?
And when you finish the race, you can move on to the next course, or you can choose to play the race again. So I made that level plus these 8 more. These last few aren't really in a fully completed state, but they're still playable. I'll probably show 1 or 2 more levels here. Oh yeah, when that little intro sequence is playing, you can also skip it. That was like a last minute thing I added. You can skip the entry reel. I had to figure out how to make it so you could skip that if you wanted to. So you don't have to watch it every time you want to replay the level. Yeah, when games don't allow you to skip those types of things, that's so annoying. Especially when you've played the game already. When you're playing it for like your second or third time, oh man, it gets so tedious watching those things over and over again.
Did you have to do any magic for the shadows?
No, Unity has a built-in directional light over here.
Okay.
So that controls the lighting
Okay.
and the shadows. But I did change how intense the light was, because by default it's really intense. So I made it less intense to make it actually look better to play with. So yeah, any questions so far?
What was the part that took you the longest to grok, as they say, to learn?
Probably getting everything to work with each other, because since all the scripts for the cart were given by Unity, I had to like make my own scripts work with those scripts.
Mm.
And then also having the collision work as well. Because like when you drive up on the road, off the road and then back on, it's like it really throws the cart around.
Yeah. I can imagine that, you know, driving through the wall would not be
Oh yeah, I had to.
Good.
And then this is the level where I started like adding slopes just to make it so that you're not just driving on a flat plane the whole time. So now you drive up this hill.
Getting some air.
Yeah. And then you just drive back down to get back around to the end.
No, all you need is your Raspberry Pi or Dino, you know, where you can create your handlebars and your your brakes.
So far it's just turning, but I think the cart script does have mentions of drifting, but there's like nothing assigned. There's no like keys assigned to drifting. So it's just turning so far. Sometimes you see those sparks when you hit a wall on the cart. You get those sparks on the back wheels. I think that's part of the drifting mechanic, but there's nothing like, there's no buttons assigned to drifting. So I didn't have to add custom physics. The Unity engine just had its own physics engine built in. So I just built off of that.
I guess if you had wings sprout out of the guy's helmet, fly over something, that would require some custom physics. Yeah.
Oh yeah, on this track I did have extra barriers, like right here at this fork. So on one lap you have to go straight this way. On another lap you have to go around this way. And then on the last lap you can choose which way you want to go at that fork.
Nice.
That was a simple script I wrote just to change the barriers. And then on this level, I put some ramps to get some airtime going. So when you go around this bend here, you hit this ramp and you can get some airtime on there.
Fun.
And the little these little tents over here. I think there were some on the first level too. They're basically like trying to act as like a tunnel so it doesn't look like you're just driving out in the open the whole time. So that was part of the assets I downloaded. There was like this tent object. So I was like, I could place that, make it look like you're driving kind of in a tunnel type setting.
Add some rain.
That could be interesting. Have some rain and make the track all wet.
And dry.
And the cart just slips around because of the rain. Oh, and you also can't jump over the walls. Like if you try to jump over the walls, there's invisible walls preventing you.
Very nice. All right, any questions?
Will you add items to your game like in Mario Kart?
Probably I could if I added AI first, then it would make more sense to have items. But right now, not really.
Or
But I think
what about or like maybe like a boost, like add like NOS or something to your car?
I could add boost panels on the track.
Yeah,
that
that'd be
you're
pretty
able
cool.
to- Yeah.
Very nice. Is everybody presented that needs to present? I have not been keeping very good track. Anybody left? I think we got everybody, unless your silence is consent. Let me say this before we fade out for the night, because I know most of us are, past our bedtime. Well, let's put it this way. This old man is past his bedtime. I am flabbergasted at how good you guys' projects are. I'm very proud of you all. It's truly awesome. And I am so glad I recorded this. I may have to do this again, do the recording part, even when we're back in the classroom, because it creates a nice history. And I'm really impressed. The diversity, the complexity, how much fun you had, how much hair you lost, how flat your forehead became. I'm truly, truly impressed. So did a great job, all of you. It's like, very good. So you are all going to go make millions of dollars and come back and make a donation, right? Make a donation to the Jeremy Lab so we can update our servers. So thank you all. And I will have the grades up definitely by the end of the week. Give me a day or two. And if you've missed anything, be sure to let me know. And we'll try to squeeze in some makeups, at least for Scott's presentation. Okay. So this is our final class? Yes, this is it. This is the last class, our last lecture, and you guys got to do it. So, all right, everybody. Have a phenomenal evening. Take care.
Thank you, Professor. Have a good one too.
You bet.
Hey, Professor.
Yes.
I do have a question. Where do we turn in the presentation notes?
Oh, you just in Canvas, you can just upload your PowerPoint or your source code or whatever, something to give me a mental note that you presented.
What about the notes we take for other classmates?
Yeah, you can upload them all at the same time. Because I was keeping roll of who showed up.
Okay. Gotcha. All right, thank you.
Bet.